So, okay, good morning, dear colleagues. So, welcome to the second day of our conference. Very welcome. And today we'll have a keynote speaker, Serafim Mostakidis. Yeah, and Doctor, the floor is yours.
Okay. Thank you very much. Okay. Is it working? Yes. The music. So thank you for the introduction, and I would like also to thank the organizers for inviting me to this very interesting conference, and I like a lot the space, have very good vibes. So when I was actually invited to come for a presentation, my first thought was that, okay, I'm a technical guy, I should give a technical presentation. And but finally, the last month, I decided to make it a little bit different. So now it's a bit technical, but it's also a little bit philosophical, a little bit theological, so many different elements. So I hope you like it. So every era of science has been a journey of knowledge, right? So in this talk, we go through this journey with a focus on AI, because AI is my field. So a little bit about the origins, principles, a little bit about history of AI, some applications of AI for my project, how we can build trustable and transparent decision-making models, and some future reflections. So I will ground this exploration focusing on a specific field. So it's a field that combines biology, physics, AI, and this is biomechanics. So biomechanics, in a sense, is a poetry of motion. And when combined with AI, is a really interesting research topic. So a few words about me. Engineer. I have 15 years of experience after my PhD. I'm also a researcher. I'm publishing papers. I'm leading EU-funded projects or some commercial projects as well. So I had the honor to co-found some companies, one in Estonia, some companies in Greece, so IDEA, SA4, Involve. I'm also acting as a consultant in a company. M2I is a company in the maritime industry. So we are building a machine vision platform for ships, for big cargo ships. So this is a commercial, let's say, project. And I'm also acting as a research coordinator in the Archimedes unit of Athena. Athena is a research center in Greece. And my focus areas are, there are many. So healthcare, energy, agriculture. Because AI is horizontal, there are many verticals. So I'm very happy to contribute to many of them with projects. So my key expertise, mostly on explainable AI. This is what I like. Deep learning, and last year I'm also interested for ethics in AI. So for me, actually, artificial intelligence is not just a tool, but is I would say is a language that we are all of us still learning to speak. And biomechanics, that is our main theme today, is among the most natural human ways to explore this, because biomechanics is about balance and adaptation. So it's a very natural way to see this exploration. So the first topic of my talk is about the origins of artificial intelligence. So the origins of AI are not purely technological. They are mostly human, and I will explain. Before we had any data, before we had any algorithm, we had wonder. So observation led to explanations. Explanations led us to reasoning. And the quest for AI that is happening nowadays is not very different from the ancient efforts where the people wanted to make sense of the unknown, to recreate what they see in nature with their own design. So the early creation of societies was humanity's first intelligent system, let's say. And this intelligence was not artificial, it was mostly collective. So really soon we realized as people that intelligence without responsibility is a chaos. And this is important to keep responsibility. I will come back to this. So let's make a move in history. So in 17th century, I think, we have a historical beef, a historical fight between two of the greatest minds. So in one side, we have Isaac Newton. So he is the father of physical physics. And there are many things that we don't know about him. For example, he spent most of his studying the Bible. So if you ask him at that moment, what's your most probably he would say, I'm a scientist. You will never. He would say, I'm a theologian. So that time, history was understood by people as theological. So Isaac's greatest insight was that if the universe, if the world or history is theological, it should have a structure, it should have an order. So if I can express it mathematically, this, then I'm actually proving that history is theological, I'm actually proving that God exists. So he introduced the laws of motion, I think, and the laws of universal gravitation. So he actually proved that with some physical laws, with some principles, we can explain phenomena, we can predict them, and we don't need a lot of data. We just need some data to prove and validate our models. But most of the primary structure comes from a lot of physics. On the other side, we have Thomas Bayes. He was, I think he was a British Presbyterian minister, and he was also educated in logic and theology again. So he built models based on patterns in data, and he needs a lot of data to train his model. So it's a different philosophy. And there is no physical reasoning, so much physical reasoning inside Thomas Bayes' models. So in one side, we have Isaac Newton, the divine order, and the fact that he believes that we can build deterministic models of the universe, of our world. On the other side, we have Thomas Bayes with divine interpretation, so truth can be revealed through evidence and through revision. So this is actually a historical fight, a beef that highlights a transition in scientific thought from the deterministic models of Isaac Newton to the new era of big data, of AI, where nowadays data is everything, and we don't care so much about physical laws. So another jump in history, we go to 1950. Alan Turing is considered the father of modern computing. And in 1950, he posed the question, consider the question, can machines think? So he was first to see machines as capable of achieving intelligent behavior. And he said that whatever we see, all that we see, all the developments that we see nowadays. Okay, we're talking about big data, but what is this data? Data can be anything, can be sound, can be an image, can be words, numbers, anything. So we have an example here. We see a picture. In the picture, there is a dog, there is a truck. So for us, it's very easy to understand what is going on in the picture. We see the dog, we see the bicycle, but for a computer, these are just pixels. So these are just random numbers. And it's a very complex mathematical problem to get a computer to understand what is going on in the picture, to extract a meaning from these numbers and to make computer see the dog, see the bicycle, see the truck. But our human brains are already doing this without us even knowing that. So a simple thought is, okay, let's copy the human brain and solve the problem, but not exactly. This is another example. For example, we see a flying bird and a flying airplane. So we wanted to build something that can fly. So, okay, we looked at birds, we followed some basics, when we came up with our own model of how to get up in the air. So it's not exactly the same model. The airplanes don't flap their wings, so it's a different model. So we ended up with an alternative model of nature, of the model in nature. So what happens with the human brain? Neuroscience is far behind at the moment. So we cannot create a carbon copy of the human brain. This is sure, this is definite. We cannot even create an alternative model of the human brain at the moment. And it was very useful, is that we designed an algorithm that is looking with an objective to find an alternative of the human brain. I will repeat this. So we cannot build an alternative of the human brain, but we have designed an algorithm that is trying to find this alternative. So we borrow the structure of the human brain, the neurons, and the network of the neurons, and we're providing a lot of data. But we have to clarify something. Human intelligence is very different from the neural network intelligence, and I will explain why. For example, we can read the book within some hours. A neural network or LLMs can consume hundreds of books within minutes or seconds. Also, the excellent contextual learning capacity, so we can understand with just a few data. A neural network needs millions of data to understand something. A small example, with my son, I went to the beach. It was a sandy beach. He was 2 years old. He knew how to walk. When he first tried to walk in the sand, he fell down, but after 3 efforts, he managed to walk. This is excellent capacity to adapt to a new environment. This is impossible with AI. Imagine a robot that is not aware of a new environment. It will fail, fail many times. And also, the human brain has a much better efficiency capacity. It consumes only 20, 30 watts. A neural network may consume megawatts. And also, another good example is to train these big LLMs like ChatGPT. It needs the annual consumption of 1,000 houses. So this is huge. So I would like to add a slide about building, how we can build an AI pipeline. So I was but let's do something else. Let's talk about microwaves, okay? Who knows how to build a microwave from scratch? It's something I don't know, but all of us know how to use it. We use microwaves to heat food. So we don't know how to build a microwave. We don't know how they operate. We don't care. But we still use them and we still trust them, okay? Because they do what they do. I mean, they deliver what it needs to be delivered. And this is a nice analogy. Let's say that our ingredients are our data. We put this data into the microwave, okay? We fine-tune the microwave, the temperature, the time. So this is our algorithm, the learning procedure. Then we end up with the final selection. This is our recipe. The recipe is actually the trained model. And we use this recipe to produce new dishes, to make predictions, okay? So this is an example. It's a very simple example, a two-dimensional space. So it's This is the distribution between height and weight in children in US. So let's say that we wanted to build a model, an AI model that predicts the weight from the height. So these are our data, so these are our ingredients, okay? We are fine-tuning our microwave, okay? So there are many possible solutions. We end up with the final setting. So this is the final trained model, the optimal solution, and we use this recipe to make predictions. So for a given height, we can predict the weight. So in case of generative AI and LLMs that are it's a huge trend nowadays, here we have given a sequence of words. We want to predict what comes next, which word comes next. In this example, for example, in the slide, we have a sentence, dog likes to eat. There are 50,000 possible words that can come next. So the model assigns probabilities for each one of them. So for example, the dog likes to eat pizza, okay, very small probability. Sushi, even smaller. Food, much higher. Meat, much higher. There's maybe no probability. So this is how the LLMs work. So this brings me to the second topic of my presentation, that is explainability. We started with Newton's deterministic models, with bias, and the bias taught us how. And now we are in the moment, explainability is the moment where these two words are meet together. So we can build models that can predict, like predictions, but can we really trust these models? Ideally, we would like to know the process of predictions, why the model is actually predicting, makes a specific prediction. So explainability, I would say, is I will call it the moral dimension of AI. It's not about accuracy, but it's mostly about understanding, trust, and responsibility. So when we are talking about explainable AI, in most of the cases, sometimes we confuse some terms, some ideas. So interpretability and explainability. Interpretability is about seeing the model. So it's like having a glass model that we can see inside. We can see how it works. So it's about understanding of the inner workings of the model. Explainability is about communicating the results. So we have a black box model. We don't know how it works. We get a prediction, and we want to explain the prediction to an end user. So it's about explaining the decisions to different groups of people. So why does explainability matter? Because intelligence without understanding is dangerous. We know that. And with explainability, we can build trustable solutions. We can ensure making. Okay, it works. It's good also for researchers for whether the model is working well or not. It can collection. So we build a model, we make some predictions, and we realize that some inputs are more important than others, so we can go back to our data collection and make adaptations. We can ensure that our models comply with regulatory requirements or with GDPR. So in most of the cases, insights are more important than the predictions themselves. So the final objective is to achieve trustworthiness. Okay, it's a term that EU likes a lot, and we see this in many calls in the proposal. So explainability can come in different phases of the AI pipelines. We could have explainability before even train a model. So it's about data explainability, understanding our data, understanding our sources, biases, limitations. We can have explainability during our training, during training our models. So this is what we said before. This is to create models that are explainable by design, so we can understand their mechanisms. For example, a linear model is fully understandable, it's fully transparent because we see all the different mathematical equations and we know exactly what's the effect of inputs to the outputs. And also we can have explainability at the post-modeling phase. Here we have a black box model. We are producing a prediction, and there are tools like SAP, for example, that we use to explain the decisions. This is SAP, what I said before. I don't want to get into details, but this is based on game theory. So in a game, there are multiple players that are contributing to the outcome of the game. This is exactly how we applied for explainability of an AI model. So there are different inputs in the model. There is a specific outcome from the model. So we are trying to see which is the contribution of the different inputs of the different players to the final outcome of the machine learning model. And this colorful, nice diagram is what we get from SAP. I won't get into details about that, but it's maybe the most popular mechanism or method for explaining, for explainability. There are others as well. And this is how explainability can be applied on images when our input is an image. For example, this is from COVID. So we have a model that can somehow diagnose COVID, can detect COVID. So apart from the decision, we get all these colorful images. So the doctor actually, apart from just the crisp decision is 0 or 1, he gets this colorful image and he can understand why the model took this decision, which are the areas of the image that are loaded more in the model, which are the areas that he needs to focus. Maybe there are some findings there. That's why the model becomes more trustable by the doctor. He doesn't get only a decision, but he gets an explanation, okay? So this brings me to the third topic, that is AI in action, from labs to lives. And this is some of my projects. Some of them are ongoing. Some of them are finished, recently finished. So I came from Switzerland. I was in a project meeting for this vocoder that is actually a breath analyzer. We're building a breath analyzer to diagnose and to detect major diseases like cancer, infections. Since AI, as I said, is horizontal, there are many verticals. So Chameleon was a project about with drones and agricultural applications, either to detect from the drone to make what is called remote sensing, so to detect information about the terrain. Or also animal welfare was included in this one. Also, Low Game it was an EU project. It finished recently. This is about training. So it's a gamification approach for training law enforcement agents. So some games with virtual reality, and we are actually following the performance or quantifying the performance of the policemen by following their movements and also capturing their emotions. I will say a few words later as well about this. Carbofopyro was an energy proposal. It is an energy proposal with wind turbines and maintenance with AI and sensors. XPANI is a project about explainable AI in the manufacturing domain with big end users participating in this one like Ford or Whirlpool. iClimaBuild was a project about designing new materials, like materials for buildings or for composites, with AI again. Also some health projects. One of the most peculiar maybe is the one for predicting mortality after heart transplantation. So there are major ethical discussions that we can make for this project, but the concept here was that we try to predict the mortality after heart transplantation. So, but we have to do it before the transplantation. So we have like a list of possible recipients of an organ. So we are predicting who is the best, let's say, recipient, who will live more with the organ. So there is a huge database in US with on thousands of patients that performed heart transplantation data before the transplantation and after. So we built a model. Okay, it was not quite successful, but it was like the first steps how AI could also help on that direction. And also we are conducting research in football, so identifying soccer player styles and how these styles are affecting the outcome of the game. So this is also interesting. So this is a video. Let's see if it plays. This is a video from a project that is about, the project is called Search and Rescue. Okay, I cannot play the video, but can you help me? I think it's playing now. So this is not super innovative, it's YOLO. YOLO is for human detection. So let's say that we have a disaster, we have an incident, so there are people that are lost. So there is a drone with a simple camera and we can detect persons. Okay, this is state of the art. It's not something really innovative, but we are using YOLO, for example, here. So we can detect people from the sky, from the drones. But there are also some challenges here because there is a distance between the camera and the object. In some cases, the object is hidden in dark environment. So there are some people, let's see if we see an example, that are not clearly seen through the drone, and the AI can detect them. And also there are other challenges. Sometimes here, for example, there are some people that are partially seen, so they are hidden under rocks or rubble or whatever. So these are the challenges that we have to solve here. So for disaster manager, there are people that are lost in a mountain or in a village, so we are looking for them. This is an example from the low game, the one I said before for the low agents training. So he's playing a VR game, and we have a camera, just a single camera, and with this single camera we can actually extract the pose, not only the two-dimensional pose, but the 3D-dimensional pose. And that was impossible some years ago, and now we have it with just one click. It's available. So he's performing some movement, and from a single camera, we can reconstruct the 3D pose. And we can use all these physical dimensions, all the physical performance of the trainee, and we are monitoring him, and we are assessing his performance. This is just an example. He's a friend actually performing the movements, but yeah, this is quite interesting. We did the same with animals. This is from the Chameleon project. So we are monitoring the gait of cows, and we are trying to detect at the early phase diseases like lameness. So we are, let's play it again. So we are getting the pose of the animal. We are following the movement of the head. That's very important. It's a very important indicator, this movement of the head. And also the symmetry in the gait movements in the legs. And these are very good indicators for this disease, for lameness. So this is the project in Switzerland. I was there 2 days ago for a project meeting. This is also very interesting. So we are trying to build a breath analyzer, a portable device, where we can give our breath. We are just blowing in a bag, in a device. In our breath, there are gases, different gases, and we are trying to detect at the early stage major diseases like breast cancer, colon cancer, lung cancer, and kidney insufficiency. So we are now performing a clinical trial in Greece in a big hospital. We are collecting breath samples. And the first objective of this project is to build the hardware. Should be portable at the moment. It's like a table, but okay. maybe in the future will become smaller, but we are trying to prove. So it's a pathfinder, so very low TRL. And we get from the technology that we use laser. So from the laser, we get some spectrum like this. From this spectrum, we have to extract the concentrations of the gases, the VOCs that we call. And from these concentrations of the gases, when I say gases, I mean acetone, ethylene, methanol. We are trying to predict these diseases. And we have very interesting results. The first results that are really working, so we are very positive. So the fourth topic is actually the main topic of this talk is about osteoarthritis and biomechanics, what I said before. That was actually my PhD many years ago. I'm still working on this area of research in osteoarthritis and AI. So this is a project within Archimedes unit research center. I'm the AI leader of the project, and my colleague Polydorus Kabaxis, he's in US and he's leading the medical, let's say, aspects of the project. So this is a project that brings together physics, AI, and biology. So it's a physics-informed AI for predictive gait retraining to combat knee osteoarthritis. So why osteoarthritis? The global prevalence is 60%, so there are millions of people affected worldwide, and 30% of adults struggle with basic mobility. So it's a huge problem. Okay, you don't die, but it's a huge problem. So the current challenge is that for analyzing movement, we just have lab settings, and these labs are very expensive. We have access to these labs. They are equipped with cameras, a system that is called Vicon, force plates, assessing ground reaction forces, so wearables. It's a very expensive setup. Also, we have limited early detection at the moment. We cannot detect the disease at the very early stages. And we have lack of personalization. And there is actually no therapy for osteoarthritis. Okay, you can have a surgery, but it is not a therapy. It's an intervention, it's an aggressive intervention. So the focus of this project is actually to prevent the progression of the disease. So as I said, we have all this access to these very expensive labs. So what we do, we have some people at the very early phase of the osteoarthritis walking. There are protocols, data collection protocols, so there are specific models that we use. There is a, let's say, a methodology that was created by Stanford that we are using. It's called OpenSim, and with OpenSim we can analyze the movement. We can even predict the pressure and the forces that are applied in our joints. We are focusing on the lower body in that project. So at the beginning we have the lab set. We get all this data. So we get data from different locations of our body, from several locations. We get, for example, acceleration, angles, forces, pressures, and different stuff. So we have many, many data. So our first task is to reduce this data. So ideally, we want to find one location in the human body, max 2, that can give us insights about the onset of the disease. So if I put a wearable there, maybe we have a very good screening technique. So this is the first task, to reduce the dimensionality, so to end up with a single location that gives us good result. The second task is to use from the selected location of the human body to make some diagnosis for the osteoarthritis. And then what follows is, once we have a decision that, okay, most probably you entered the disease, then we are running some predictive simulations, and we simulate the way that the patient needs to adapt. He needs to change the way he walks in order to lower the progression, to slow down the progression of the disease. We are performing these simulations for the specific person, and we are ending up with a gait retraining protocol. And we are applying this protocol to the patients. So these are a little bit more information. about the different steps that we follow. There are two parallel streams associated in this project. The first one is the early detection part. So it involves this data dimensionality reduction to select locations in the human body where we can add a simple wearable, to perform the classification, to identify whether he is healthy or not healthy. And the second stream that runs in parallel, it uses these predictive simulations. So we are using information from his knee and from the specific patient. And we are trying to run simulation to see which is the ideal gait pattern for the specific patient. And we are applying these gait alterations to him or her, and we are quantifying the effect. So just to connect it with what we said at the beginning, we are using in this research some basic models. For example, we are using finite element analysis for them in our knee joint. So this is what Isaac Newton would propose. For example, this is a deterministic model, is a mathematical model. So this model, if we run it many times, we get some inputs and we get some outputs. So we are changing the design parameters. These are our inputs, and we are getting some outputs from this model. We can use this input-output data to train an AI model that will be a fast digital twin of the deterministic model. We can also use additional inputs if we want. And then we can actually perform some explainability analysis to understand how this AI model works. We get these insights as feedback, and we give them back to the designer of the initial model. So this is somehow a way to combine deterministic models, mathematical models or simulators, with AI and explainability. And also, since we have trained an AI model, we have applied some explainability. And for example, that's why I had this slide. We get some explanations. We get some diagrams. But I have realized that these kind of diagrams are very difficult to be understood by a clinician. Okay, he said many times, okay, what's this? I don't have a clue. The same happens in other domains. Like we had another project in manufacturing, we get the same feedback. So, okay, these are useful for the researcher, but for the final end user, they're not so useful. So what we are actually doing is that we get all this explainability raw data. We get also the decision from the model, and we are formulating them. We are somehow adding them to an LLM with a proper structure within a JSON, let's say, structure. And the LLM is transforming this colorful diagram to a textual explanation. And this explanation could be adapted to different user groups. For example, a doctor would like to see something like that. The patient was diagnosed with X because a strong association was found here and there. A patient maybe needs a simpler explanation, but you can adapt the LLM to give different explanations into different groups of people. So, okay, to the last part of my talk. That is the future of AI. So this last part actually looks ahead. With Newton and Bayes, now we are in a frontier. Our creations are not only intelligent, but also autonomous. So the main question is, can we trust? So it seems that we are moving from AI systems to AI societies. As we said, the AI is not just a tool. It's becoming an ecosystem. And as these AI systems enter our societies, their explanations are becoming part of collective dialogue. So we face many challenges. For example, we prefer simplicity in the explanations or in our models, but these actually hides problems like biases or other problems. We imagine AI thinks like us, but as we explained before, it doesn't. The different intelligence. We focus a lot on explaining algorithms. We don't focus on understanding the effect on human values, on people. Even our best explainability models, sometimes they disagree. And this is producing conflicting truths. And we can say that explainable AI is still like a baby that is full of potential, but is not fully self-aware. So what is the next step for AI? Personal opinion, more data. So responsible AI means that we are designing systems that are not only capable of adapting to new inputs, but they should be capable to adapting to human values. It means shifting research from algorithms to empathy or from predictions to participation. And since we're talking about participation, collaboration is very important. Different engineers, clinicians, policymakers, philosophers. I mean, all the different groups can contribute because trustworthiness won't be achieved only with code, but it will achieve when the creators are really there, they are accountable, they are responsible. So every technological revolution comes with a balance of promises and threats. So in healthcare, we have many threats, such as data privacy issues, security, fairness. Most of the cases, our models are not fair. Explainability and trust issues all should comply with regulatory, ethical requirements. So the clinical integration is a challenge, and the user adoption. But there are many better personalized medicine, better decisions at the very early stage, as we are hoping. Decision support for doctors, cost reductions, but at the end of the day, we should not eliminate one side. We should not keep one side and eliminate the other, but we should keep a balance. This is the most important, and that AI won't replace the human element, but it will somehow reveal, and this is more clear than ever, the consequences of our choices. So he is a very well-known professor. He's publishing books. I bought all of his books. And he's also giving nice interviews. Actually said that AI has hacked the operating system of human civilization. Which is the operating system of our civilization? It's our language, because we are using it to communicate, to even think. So what he says is actually simple. He says that for thousands of years, stories, beliefs, and shared memories and meanings has shaped the way we live and collaborate. Now we have autonomous systems that generate these stories. They can shape narratives, they can influence our beliefs, they can even define what we think is correct. It should not be to build a better model, but at the moment, we as humans need to define meaning in a world that where stories are not uniquely ours. So this is the big challenge for the humanity, according to Professor Harari. And we started this many thousands years ago with faith. We started with faith that the universe has a structure, has an order that we can understand. This faith gave birth to reasoning, so better methods for observation, experimental mechanism. This led to more data, and now this data became intelligence. So the cycle actually closes with responsibility, with our responsibility. Because, as I said before, the early creation of societies was first humanity's system of intelligence that was collective at that moment. Now we are actually entering a new era where we have new kind of society, the AI societies. It's like a hybrid ecosystem where people need to somehow live together with AI bots. And so this is actually a new society that is coming in. And we have to be also very responsible, because responsibility is a key. We are the architects of these systems. When I say we, I don't mean AI researchers. I mean, we as people, we are the architects of these systems, and we have to be very responsible. So some concluding thoughts. Is AI intelligence? Yeah. Yes, I gave some explanation about this. Okay. Yes, but it's not human-like intelligence. It's different. Does it have emotions? Not at the moment. Okay, but it can simulate emotional conditions. Is it flawless? For sure, no. It suffers from many biases. Can we trust AI? Not blindly. As we explained, there are many biases, many problems at the moment. So will AI surpass human intelligence? Not at the moment. It's a big question. There are many debates about this. Maybe in the future, I don't know, I cannot reply to this. I'm still skeptical. Should we be scared or excited? This is the final question. That's on us to decide, actually. And that was all from my side. And you can find some details, contact details of me. I'm involved in many projects. Since I have launched some companies, I'm talking with VCs. So I'm always open to collaborate with anyone who has a nice idea. So if there is an opportunity, I'm here to discuss. So thank you very much again.
Okay, so thank you very much, and I hope that we will have questions regarding this presentation for our colleague. Okay.
If you hope so. Thank you very much for presentation. You mentioned that data is most important for prediction. Could you talk a little bit more about data structures? How do you structure the data, and what data structures do you use?
Okay, yeah. Yeah, it depends a lot on the application. When we are talking about healthcare, okay, should be more strict. There are many. Even when we are trying to collect data for a health project, we have to take some actions. Before that, we have to take approvals, etc. So the way that we are trying to structure our data is actually using standard protocols. So we are using JSON files, or you're using a lot of data modeling structures. So everything can be properly organized. But it really depends on the problem. I mean, the more that you're organized, and the better. And most of these research projects, we don't care so much about data structure. But when you are trying to build a commercial project, there data structuring is of paramount importance. So because apart from the actual prototype or the model that we're building, this model should be alive, should be operational. So we are also applying this MLOps strategy. So data is coming in, so we're training our models coming out. So we have to be very careful with the way that we store our data and we structure it. So, there is no specific answer to this. It depends on what you want to develop. There are many different tools, different data protocols, but the more organized you are, is the better, yes.
Okay, we have more questions.
So, no, this is simply some comment. So, I think we should not be scared of AI, and more to this, we should not scare that the AI will surpass us, and we should prepare for this. We should be ready for this right now. Thank you very much.
Yeah, I totally agree. That's why I was many times in the talk I said the word responsibility. We should be fully responsible of what we are doing. I'm not a pessimistic guy, I'm an optimistic guy, so I want to see this progress as positive, but I'm just warning myself and the other people that we should be very responsible, we should be very careful, because there are threats and opportunities, as I said, yeah.
Yeah, thank you. It was very nice talk, and glad that you are working on a lot of projects. And one thing what I would like to share, I really appreciate that your idea, your mapping with the religion part, because if we cannot measure, probably we can believe it. That's a good point, and I'm glad that you did and present it. My question is, do you make verification of the results? Because the project what you are presenting and probably the workflow, you are never mentioning that you are somehow verified. And I believe you doing this because in our way, we are back to religion, you believe in the result that they are very correct.
Yeah, very nice comment. Yeah, of course, we are following different verification mechanisms. There are different phases of verification. First, you have to verify your data. Okay, yeah, verification of data, then validation of the machine learning models. There are different techniques like cross-validation, nesting cross-validation, hold-out techniques. And then at the very end, you need to go out there and try out with patients in the case of the osteoarthritis research. So, for example, in this vocoder, let's say, project, we are having different clinical trials, different phases of clinical trial. The first one was to collect data. So we are training our models and we are validating them with cross-validation techniques. That is common in AI. And then we have a separate trial at the end of the project that will be only for testing. It's a completely unknown set that we will use to actually validate our model. So there are different phases. So validation on your data, whether they are correct, etc. So validation of the models using state-of-the-art mechanism. And of course, actual validation on the population. So these are the phases that we follow, yeah. Thank you very, very much. Oh, thank you very much.
Small gift from our university. Thank you. Okay, so now we'll have half an hour time break, coffee break, and then we will continue. We will continue working in sessions. Yes. So from 11 a.m. we'll start a special session on e-learning methods and technologies, which will be chaired by two other colleagues, Senyan Hakan Aydin and Ramūnas Kubiliuk.
technologies. And as I was introduced, this session will be chaired only by me, Ramūnas Kubiliūnas. And we have 4 presentations and quite a strict time, about 15 minutes for each presentation. But if presenters will take all 15 minutes, we will not have time for questions. So 4 presentations, and first one is will be made by Laura Danusevičiūtė Brazaitė. Please, floor is yours.
Okay, so it's nice to see you. Hello, and nice to see the known faces. So it's like a challenge. Always you want to do in better way, so we'll see. But you know, the challenge is that the people which you know are watching you and listening you, but okay, so my name is Laura Danusevičiūtė Brazaitė, and today the main idea, the main topic which I would like to share with you, the research which we have made with the teachers, and the main focus was to look, to estimate their visions for the future from the artificial and inclusive education perspective. So, of course, I wasn't alone. I had the colleagues with myself, so it was Lina Gaižiūnienė and Raminta Pučetaitė. The main idea why we had started such kind of the research, that of course we all of us, we're understanding that artificial intelligence is transforming education. And in which way? So, of course, the tools which are based of artificial intelligence, they support students, they assist teachers, of course, for improving the accessibility, efficiency, of course, and the engagement. But where is the problem? Of course, that the main key trend that is it is shift toward personalized learning, where of course the individual student needs is the main focus. So here the inclusive education is the main key in artificial intelligence, and we see that inclusive education is like this course which could help to put the technology and the social needs together. So this is why we see as the very important key as the inclusive education. But what is the problem, and what kind of the main idea which we thought that we need to follow, that we see that the teachers, they are skeptical in one way, and this slowness of technologies implementation, technologies adoption, it could be one of the reasons that, of course, they are skeptic, and of course they don't see the main opportunities which could give the technology by themselves. So, of course, where the main key was that we thought that, okay, so we need to look how the teachers' vision, how the teachers see the technology from the future perspective. So what does it mean? So it means that what kind of the situations they are recognized. So here we thought that scenario analysis will be the main idea, that could help us to identify the probable, possible, and desirable futures, which would be the main conceptual space for innovative solutions. So here we have the future studies as the framework, which we have used as the methodology for our study. So here we wanted to understand and to investigate the trends and the drivers of the technological transformation, and of course to see what kind of the visions, how far teachers from this scenario analysis see the future where the artificial intelligence and inclusive education is developed together. So the main aim was to examine inclusive AI integrated education through the lens of future studies. And the method which we have used, so it was the narrative research method, which we have applied and we have adapted to the context of future scaffolding skills. So just shortly, what does it mean, this future study as a method? So it means that we gave the idea, we asked for the teachers that they will vision, they will think about the future, where the scenarios, where their future as the key would be as the possible, as the scenario from the time perspective, the probable, considered to the time perspective, and of course the preferable, consider the time perspective. So it means that, as they had already mentioned, so we used the narrative method, and we were asked for the teachers that they will imagine that they are traveling, they are going through the time perspective, and of course we have asked, so how the future, how this educational future will look, where the technologies as the artificial intelligence and inclusive education will be implemented. So after the ICIST, after the ICIST, we have asked that they will categorize their futures scenarios based on thematic dimensions. So as you can see, we have 6 thematic dimensions. So the technology integration, the personalized learning and differentiation, pedagogical methods, learning spaces and environments, social emotional aspects, and of course the life skills and global competences. Okay, so we got the essays, we got their scenarios, and they were full of interesting informations. So therefore we have categorized them to some macro themes. So main macro themes were science and technology, emotional states, values, emotional factors, perspectives, relationships, others, time routines, nature, and relationship role. And also, as you can see, some of the macro themes also have some sub-themes. So we had 50 teachers and their essays. So mostly the age was from 41 till 65. Of course, mostly there were females, and the teaching experience was ranged from 1 to 50 years, but the main participants, they had more than 20 years of the experience of their teaching. Okay, so of course we use some statistics for the qualitative thematic analysis, as the chi-square goodness of fit test, the crime and we, and of course the Spearman's P correlation. Right, so, and the results. So mostly teachers, they do see the artificial intelligence and inclusive education as a support which gives for their educational process. Of course, they see AI as an assistant with the students monitoring and differentiation instructions. Of course, for analyze the data, for provide more personalized learning opportunities to promote inclusive education. Also, they see AI as a helper for designing different tasks. Of course, as a supporter, inactive as consult and moderator. So which also was very interesting to see that the teachers, they recognize such kind of this tool, but also they see that the values and their view as the teachers already changes. And of course, they see some challenges. So one of the challenges that they don't have time to search for technological tools. Of course, they don't have time to master some appropriate tools. And of course, they do see that there is a challenge, a problem for critical thinking, and of course for responsible use of artificial intelligence. Yeah, they do see artificial intelligence and inclusive education, that there is some threats and limitations of artificial intelligence. Yeah, they do see that it's important for human resources and thinking as a tool that, this tool also could help to increase the human resources and thinking as the global value. And of course, the AI's impact on learning and knowledge also is very important. Okay, so the macro theme, the macro themes, so the main macro themes which we have recognized in the ICIST. So it was the emotional states and emotional factors. And we got the goodness of fit, like 41.3. And also what is interesting that the experiments, the correlation show that we found the correlation between emotional states, emotional factors, as the macro themes, and of course between technology, science, and perspective. So what does it mean? That it means that the teachers, they see artificial intelligence as important tool which changes the environment, basically. But what is very important that the emotional situation and emotional factors also trigger very much. So here you can see some interpretation of our macro themes. So again, so these the main macro themes like emotional state and factors. So it means that they do see that it's very important, the strong emotional regulation, which has a big power for well-being. For the teachers and for the students also. Okay, so as I had mentioned already, from the macro themes, we also developed the sub-themes. So the main sub-theme in emotional states, it was the calm and relaxed. What does it mean? So so the teachers, they feel safe by using and developing the artificial intelligence tools. So it means that the future, they are not afraid. They are not afraid of this tool. They see artificial intelligence as the tool to increase the efficiency. Of course, it's the transformative element as the tool. And basically, also we developed the visions. So the main vision, it was the dynamic vision. So it means that they see the tool as the transformative tool as the artificial intelligence, and they don't bother anymore. And of course, and the main idea where also they have put the understanding, so the technology integration, it was the main theme from their perspective. Okay, and the conclusion, it will be that, so the teachers, they see the success of artificial intelligence in education, but anyway, they see that it will depend on their empowering themselves to co-create technology and, of course, to promote the meaningful learning experiences. Thank you. Sorry.
Thank you very much.
I've seen that you showed me.
We have a case when we don't have time for questions, but still, maybe anyone? Okay.
So, very nice presentation. My actually question is about the feedback that you got from teachers. Mm-hmm. Are they mostly positive or negative?
No, they are very positive actually. This calm and relaxed, so it means that they feel by themselves relaxed, they don't feel fear, it means that these new challenges, these new technological challenges, so it's not the dystopic, it's not something what they will bother them.
Maybe they will replace them.
No,
they don't feel that they are threatened.
No, they don't want to replace them, they feel calm, and they know that the future will be fine.
Okay, that's
for
good.
them and for the students.
Thank you. Maybe one question from me. What would you suggest for teacher whose students are the initiators of using artificial intelligence tools, not teacher?
Hard to answer, maybe I also would like to ask why the students, they are the main initiators of the technology, why not the teacher? Maybe one of the questions will be that, to figure out the situation, to understand the situation. But the teachers, they are main agents for the implementation of the technology. So it means that they will be the right-handed people or the left-handed people, it depends which hand you are using. So they are the main agents. So they need to follow, they need to improve themselves in this technology also.
So we could not say that calm and relax.
Yeah, but our idea was that they will think about the future. So they feel that the future will be fine. They see that this technology makes the changes. They understanding it very well. So it's like a transformative element, as I have mentioned. But they feel comfortable in the situation.
Okay, thank you very much for your presentation. And the second presentation will be by Martin Griesbacher. I hope I pronounced correctly.
Yes, you have. So thank you very much also for the opportunity to present some of the research of mine and from my colleagues. You can see the names up there. So it's a bit, mainly it's about learning humans. So I guess it fits very well in the education panel, but it's also, of course, about the bigger question of how do we keep digital infrastructure secure. This is why we have the topic of cybersecurity. Let's try to get as efficiently as possible through the, I guess, one or the other too many slides I also have in my presentation. First of all, my presentation is about trying to get a general, more improved understanding of human factors in cybersecurity, because we know that the threat landscape is rising, the technology landscape is always changing, it's getting more complex. And the incentives for attacks are also rising globally. So we need to find measures to tackle security issues while we rely so much on digital infrastructures. The main point here is that I introduce an interdisciplinary approach and an integrated approach to human factors in cybersecurity. So, generally speaking, the problem which is sitting not within the computer but in front of the computer. And it's also about establishing a more dedicated and more differentiated approach to human factors or human factor-related threats and according mitigation strategies. In terms of context, so the research domain is about cybersecurity. So in general, what we know is about protection of digital assets or digitally accessible assets. So we know as people we are also accessible through digital means and can be harmed through technologies, especially if we are driving with an automated connected vehicle, for example, then it gets very material, this digital domain. And I put in brackets here the financial sector because the research is originally started in the SOTA project, which was a Horizon 2020 project. Maybe skip forward. Horizon 2020 project, which was about raising cybersecurity resilience in the finance sector. But we can also apply all the outcomes we worked on to any organization in any sector. But of course, the more critical the infrastructure is, like the finance sector, health sector, the more relevant it gets. Especially the bigger the organization and the more resources they have, the more they should be capable to address this complex field of problems. So, for the beginning, of course, because it's not very self-explanatory, we hear this word human factors a lot, also cybersecurity, so it's important to introduce what do we mean by it. In general, when we look at research, so it's less on the technology side, so it's less about zero-day vulnerabilities or API interfaces or any other technical components of IT infrastructures. It's more connected. You can understand in the first approach, like when keywords fall like social influence, attitude, personality, perceptions, user resistance, cultural aspects as well, psychological vulnerabilities, or also societal dynamics, like we know about the world we're living in, where disinformation or misinformation is a very prominent problem, or other dynamics which are aggregated through a myriad of different cultural and technological factors, like surveillance capitalism, which has been analyzed very profoundly by Shoshana Zuboff. When we try to get a more structured approach to human factors, we can differentiate two main complementary approaches to human factors in cybersecurity. One is I want to understand human behavior when they interact with technology and how this causes, for example, problems for security. There we often see this focus on the problem which I just mentioned before, sitting in front of the computer. Also this approach, this the quote we often hear, the weakest link in cybersecurity of humans. And the second one is complementary to this because it's about when we learn about how these human behaviors work, how can we design trustworthy or imply human design principles to technologies so we can keep not only digital assets secure but also actually the humans which work with those technologies and for those the technologies actually have been invented. Another point of human factors is that we try really to understand properly or seriously what cybersecurity competence means. For example, sometimes we just think it's about updating people with skills and knowledge. I guess the education researchers in the room know this very well. We know you can have the best skilled or best educated employee in your organization. If he's highly stressed and doesn't have time to deploy his skills, he still will be very vulnerable towards cybersecurity attacks. So the context matters. It matters if the individual gets the agency within the organizational or cultural context to enact on his skills and knowledge and so forth. So this is also kind of a sociological baseline. And overall, it's about focus on understanding and mitigating harmful events and processes. So what we typically see with words like incidents, threats, risks in the information security domain, but where human behavior and human dispositions make a significant difference for the outcome. For example, when we look at zero-day vulnerabilities, no one in your organization, university, outside of the IT department can do anything against that. It's purely technological. Of course, it depends on the organizational structures, how fast you are to fixing updating the gap in your infrastructure. But on the other hand, I'm looking more on the things where humans, for example, a very simple example, click on a phishing link. So they are the prime vector for an incident to happen. In the project, we did a lot of systematic work trying to standardize information to see like what are the incidents which are actually where the human element is the critical component for a successful attack or an incident to happen. Of course, I will not go into details here. It's more like a quick view on that. But I want to go forward and see what happens when we look from an interdisciplinary perspective on the problem of cybersecurity. So it's mainly about going beyond a primarily technical understanding of information security, which is focusing on this CIA triad of protecting the confidentiality, integrity, and availability of digital assets by integrating human factors, which I just mentioned, and also European values and fundamental rights, because this is the bigger political and cultural background where IT is deployed within the European Union and its associated countries. One very important part of this is that when we look at security topics in the digital domain, we don't look just on technological vulnerabilities, like soft and hardware, but also some physical aspects of door and data center security aspects, but also on vulnerability layer, which are situated in the social and legal and ethical domains of an organization, for example, the people working there, and also some more subtle and more difficult to tackle issues like ethical and legal issues, which I can't go into detail here right now. One important axis is also that we don't look at just the integrity of the organization. It should be like, we need to keep the digital assets of this university safe, but also looking about individual integrity by also respecting the fundamental rights of all individuals involved. So this is more the extended view which we have in the European context. So in principle, it's the message, it's not just secure, it's about signaling a trustworthy European digital environment. So this is a context which I see here and which of course was important in our research because it was a European funded project, and within the European context we cannot think outside the box of the source code of the European Union, which is human dignity and fundamental rights. So the message is you will not be harmed, not just your data is secure. And what other aspects for me very important, which I sometimes see missing in the technical discourse, is that we accept the inevitability of human involvement and agency in all these digital processes. Because sometimes there's also these ideas of zero trust systems, which reduce the human element, maybe even dreaming of a process where there's no human element, but which goes completely counter any ideas of how we want to live or how we regulated actually societies in the European Union, because we talk about human agency or human oversight, for example, when we look at the AI Act. So humans need to be still able to make decisions, to monitor effects, to change outcomes, so there will always be a human element. And we cannot eradicate it because we would have to eradicate ourselves to get there. So this is also a more systematic approach, just as an impression what is happening in our research, and also I referenced the paper in the paper I submitted for this conference. One main thing was to get this more differentiated perspective on the main areas of concern we have when we look from a human factors perspective. One for me was that we get away from this, what I call human threat bias, where we first look at humans as a problem. So like, I have an organization with 100 employees and they're all problems and threats. That's not very constructive, but it's a perspective which is out there and very manifest. But more looking at the different types of actors which have different backgrounds, because this has concrete effects on how I can tackle or mitigate the problems associated for them. So the main problem we have is human error. People having done mistakes. And this can have very different reasons. For example, clicking on a phishing link, this doesn't make you an insider threat, but a person who made an error. And it's a very important difference, because you can train someone who does an error, but the malicious insider, if you truly intend to harm your organization, you cannot train to not do it. You can just try to imply some monitoring aspects or shape the context in a way that they maybe not get disgruntled and start to hate you and therefore attack you, which often happens in modern capitalist organizations as well. Legal and ethical threats, again, a bit out of scope here for the presentation because it will just be too much. So the main approach you have, the strategic avenues to follow when you want to tackle it is, of course, you need training, enhancing knowledge, skills, and attitudes, but you also have to look at the problem of shaping the context, because skills alone are not enough. Of looking at what the cybersecurity culture in your organization should look like to make incidents less likely in the future. And this implies not only training of employees in general, but also training, of course, of management, because they have to shape the context, have the right style of management, so so that people feel motivated to act towards proper security compliance procedures. And of course, for problems like in the regulatory or ethical domain, you just need specialists to tackle this. So I will not go through this completely. I made we summed up 7 recommendations for what we can look at when we really want to seriously try to solve the problem of improving human resilience or human factor-rated resilience of an organization. Because sometimes it's just like, okay, there's an ISO standard, we are ISO certified. Once a year I need to do a training, then send out this training, then I have my compliance check mark, and then I'm done. I'm not really interested if anything changes in the skills or behaviors. I just want to make sure that I get my ISO certification again. This would be like the different approach to saying, I really want to make sure these things work and really help people and really make them better at solving problems and really make sure that they have the time, for example, to engage in proper cybersecurity procedures. So, in terms of summary and outlook, let me begin with the summary. So in the end, what we have in this paper and in this research domain work for quite some time and still now in the wireless context currently, is a proposal to extend the traditional information security perspective to the maintenance of a trustworthy digital environment, also based on European values and fundamental rights. So we consider a wide variety of vulnerability layers, but also things like human awareness, behaviors, and human dignity. Then we have proposed a differentiated perspective on human factor-related concerns about seeing where is error, where is really an insider threat, and where are other types of threats, like ethical and legal threats. And also trying with these recommendations to give a multifaceted and respectful implementation of trainings in combination with managerial shaping of cybersecurity culture to identify that as the most promising strategy for mitigating human factor-related threats and not just compliance checks. And in terms of outlook, I guess we can emphasize 2 main points. One is really an issue, it's the cost of serious training efforts, because they are significantly higher or at least more complex, require more effort than just passing compliance controls, which I said I can just send out an online course and have like a signature that everyone has seen it and that's it. It's enough for ISO 27001, which is the leading standard, and you now see that's not very much. So you have to look at the development of more open standards, standard methods, also sectoral collaborations, not trying that every company organization has to solve this problem on its own if they don't have like a lot of resources, because there are small and medium enterprises as well as public institutions. So there is a requirement for that. And also a requirement, and I think this fits well in this panel, for enhancing the capacities in public education to raise baselines for organizational training. So they come with more knowledge, more skills already in your organization. You don't have to start from scratch, which is most of the time the case today. And by the way, I'm not sure about how AI will help with that, but I hope not people don't think that AI can really help them to get to, I don't know, accelerate learning or something like that. Learning takes its time. You cannot cheat a learning. You can get a quick outcome like a cheat sheet on which you write in your test, but you will not have learned anything. So there will be still the human learning of neural nets in this GUI stuff in our skulls, which is very important and remains important. And here, what I said, honorable mention of new growing risk landscapes. The problem is complicated, but it's so worth the effort to make a good working solution out of it. AI, here more emphasized as a problem. The stochastic parrots will create a lot of unknowns and a lot of problems we are not aware yet of. And also AI deceptions. I did a presentation at Athens a couple of weeks ago where humans just have the wrong images of what they get from AI and what AI actually is, and therefore get some very bad outcomes when they try to do something constructive with it. And also the problem which we have in the cost action where I'm part of, being wise, the problem of next generation wireless networks. I'm talking about 5G, 6G, about how we have here today and in the coming years a massive increase of interconnected devices, interfaces and data sources, which complicate the problem even more. Even I carry around multiple data sources and monitoring tools at once every day where I'm going, and 6G doesn't reduce the problem, especially in combination with AI on edge devices with their own non-standardized operating systems. So, and in this very quick run around, thank you very much for your attention. I'm happy if you ask questions maybe outside then, because I guess I have already gone beyond the time.
Thank you very much for your presentation, And thank you very much for controlling the time. And questions will be during the coffee break. So the third presentation will be made by Justina Janik, and this presentation will be online. Therefore, I need to turn on Zoom and ask if Justina is ready. Can you share your screen and slides? And let me remind you that you have 15 minutes for your presentation. So, floor is yours.
Hello, everyone. I'm very honored today to represent ICE project team. The topic of my presentation is the practices of applying artificial intelligence in engineering education. I have a honor to represent the team from Lithuania, Poland, Spain, and Germany, which is the project team of grant according to K8 220 strategic partnership in higher education program supported by Erasmus Plus agency. And our main focus is artificial intelligence in higher education. So I would like to tell you a little bit about our project and the implementation we did because of the project and our chatbots in higher education. So our team is aware of the huge transformation which is like going on now in terms of methodology and all the learning and experience, because we started to use AI-based tools. We were aware about the challenges in this project as a data privacy, ethics, and teacher readiness, because it's not so obvious that all the teachers are ready for this AI transformation of the didactic process. We saw the huge potential in AI-based tools as adaptive learning and automation of administrative tasks, but we also saw some limitations like a critical thinking and hands-on problem solving. So our focus in this project was mainly to finding a balance between innovation but also responsibility. Let me tell you a little bit about our methods. So our approach were mostly exploratory and descriptive, because we were focused on case study on the use of educational chatbots. On the left side in the corner, you can see 4 universities: Florida University area from Spain, Kaunas Technological University from Lithuania, who is the host of today's conference, Bayreuth University from Germany, and Pontifical University of John Paul II in Krakow. And you can see in which study programs and which kind of modules we decided to prepare and to train our chatbots to be used by our students. In this project, we also collected data from students. So after preparing chatbots and after implementing them into our models, we collected feedback from more than 100 students to know more about their experiences, about how they use chatbot, how they feel, do they find them beneficial, and to be able to form some kind of conclusions and pattern. Just to let you know and to show you how it looks like, on the left side you can see the typical chatbot prepared by us. So all the answers which were given to the students were provided by trained chatbots, so the environment was kind of closed, and all the information which chatbot used were prepared by us. So all the content of the courses were before intentionally prepared. So we didn't use any external information as usual, AI-based tools like ChatGPT and so on. And on the right side, you can see the structure of the typical course. So we can see lessons, slide, learning materials, general information about the course, and also answers provided by the chatbot. And for example, our colleagues from Bayreuth University in Germany prepared the chatbot based on their course on microcontrollers, and students' feedback were kind of very positive, because they, of course, noticed that in this kind of environment, when we earlier prepare all the materials and we will train our chatbots to work on them, students will receive more tailored feedback and, of course, more accurate than by using AI tools which are open to all kinds of resources. So few of our results, we can see, of course, the huge potential with academic support, with course selection, planning, and guidance for our students. We see that if we will prepare the chatbots and train them based on our materials and intentionally, students can receive tailored feedback and in real time, so they don't need to wait for the feedback from their teachers. We can see the benefits of research support, so students can find their materials more organized, because they can always ask chatbot for finding the information or organize them. And we also think, based on the feedback from our students, that this kind of tool can encourage our students to do the self-studies and self-regulated learning, because they have access to all the materials and real-time feedback all the time. They don't need to wait for the teacher's support. Also, we can see the potential in this kind of tools for work with students with special needs, because a chatbot can assist the students to work in their own pace and according to their own needs, and can support them in writing, in communication, and be their virtual assistant even if they are not able to come to the class. A little bit about the scenarios and opportunities. Personalized learning adapted to styles and pace. As I told you before, we can see the huge potential, because students can basically decide when and how fast they are able to learn. We can see huge potential in automation of administrative tasks, because simply we can upload all the information about administrative process to our content or course and train our chatbot to answer for this kind of question. We can see the huge power in supporting self-learning, but also we can see limitations in accuracy, ethic, and privacy concerns. So this is the hugest responsibility on the side of teachers, to be aware, to check their accuracy, to check how the chatbot works, and to be aware that some kind of mistakes can still occur. Short conclusions, just to resume all I already said. So we can see that generative tools, especially chatbots, if they are well trained and if they are checked in the safe environment, they can increase the personalization of the educational process. We can see the risk, because they still can be some technical issues and privacy issues. So this is the responsibility of teachers who are using these tools. We can see that the chatbots promotes motivation, because based on our students' feedback, they felt extra support if the courses they used were powered by AI-based chatbots. And it requires teachers' involvement because, of course, preparing the course with extra AI tools needs some extra work and done by by teachers, sorry. Basically, that's it. I hope I did my best to present the work of our team, and I would try to answer the question if some of them will be.
Thank you very much, Justina, for your presentation. Where are applauses?
Thank you.
And maybe we have some questions. Okay.
One question I would have, I think you mentioned neurodivergent personalities like ADHD and autism, that they might be helpful, but it seems overly optimistic what you write. As for example, I have ADHD. I think the ChatGPT, etc., are very good of diverting my attention away from the actual problem. And also another problem might be, but in other personality disorders, AI sycophancy, AIs are trained to acknowledge everything the human says and tell them what genius they are for every questions they ask. It's not very helpful when you want to have relearning. So I think you can fall into a lot of risks when you don't reduce it to some very concrete cases to use it.
Okay.
Can I start to answer? Yeah.
Yes, please.
That's a great question. That was a huge kind of concern in our consortium. And to be honest, we started our research based on that. So we divided all the disabilities on 4 categories. One was like problems with mobility. The other was sensoric disabilities, like problems with eyes or hearing. We also checked the autism spectrum and so on. Now I forgot the 4th one because you need to forgive me, sorry. Let me carry on. We did check the level of knowledge in general of our teachers in Europe based on our consortium. And now we are facing the information that all the teachers are not aware of how to work with the students with those problems in general. And mostly they self-rated or self-evaluated their level of knowledge on the level of 2 points in 4 points Likert scale. So their knowledge in general, how to work with the students with disabilities based on our research is really low. So now we're gonna to work to prepare some kind of scenarios how to answer for this kind of lack of knowledge in teachers' competences. So I can encourage you to follow the other website of our project in Edu, where we will work on how to adjust this AI-based tool to be friendly also for this kind of users.
Okay, thank you very much, Justina. We are strict on time, therefore I will ask to send questions by email if anyone will have. Thank you very much.
Thank you for letting me be there.
Okay, and the last presentation will be made by Tomas Blažauskas, who is not mentioned in the co-authors of this presentation, but is co-author of results which are made in this works. Okay, the floor is yours.
Okay, so hello everyone. It's really nice to be here, and I'm a supervisor of the virtual reality laboratory, therefore we do a lot of things with virtual reality. So today I will talk about truck driving training, and the idea is that we can use technologies like computer games to train those drivers. And the idea why we need to do in virtual reality is that you can't cheat that much in virtual reality because like in virtual reality you have the fear of height. So if there is some situation, your body still has those feelings, and the idea is that we just put the drivers into such kind of situations and teach them not only the technical knowledge, but also how to perform in some stressful situations. So basically we had a project, Roadmaster VR, and the idea is that we are driving with a lot of trucks and we gather the road videos, we gather the biometric data, and then we analyze the biometric data and see which situation is good to be taught. And we have the library of these situations that we reproduce in virtual reality. So here you see some programs where we do it. There will be other presentations that will talk about it more. And this is a process, so basically it's the same, like we detect those situations, model virtual reality situations, and integrate it in learning management system. Here is the kinds of theory that is made. So basically we have those normal elements where drivers can read about something. Then we have interactive 360 content where you can't drive, but you can see how other drivers do it. And then we have fully interactive 3D content where you drive with specific simulator. So today I will talk about this part. So here you see the simulator, how it looks right now. And this is just from the conference, which was, I think, yesterday, so it's pretty fresh. And you can see the simulator. It has almost real truck driver wheel. It has also those real gears. It uses the haptic chair, which can a bit move and shift to simulate some hills, for example, and so on. Oops. So basically, when we began, we tried to see how good it is for learning, how good it is as a tool, and how really immersive it is. So for our initial testings, we didn't have yet the simulators. We had that Moza wheel and Moza pedals, and we used virtual reality glasses for that purpose. Here we recreated what we see is, I think, Elektrėnai. So it's also Lithuanian city, a part of Elektrėnai, and we made the path where drivers need to go to drive one part, and then we will use some questionnaires. So here how it looks from the driver eyes. So here is that roundabout you need to cross. You see from the first player view how it looks like Elektrėnai. And we tried with around 50 or even more drivers. And we use such well-known scales. First is system usability scales to see the usability of that simulator, how easy it is to use. Then we had the iGroup presence questionnaire. It has 4 subscales: spatial presence, it means how the space around is in comparison to real one. What is involvement in comparison to realism, and overall sense of presence. And for virtual reality to be used in the teaching, we need to see is it good for the person? Does it feel comfortable in that simulator? So we used VRSQ, virtual reality sickness questionnaire, to evaluate on 2 subscales on accumulator and disorientation. And here are the results. So basically, SOS, it was one of the first of our versions, let's say, because it was testing made in the spring. And the result is that usability is very average. It means that according to a theory, the average is 68 and we get 69, so it was completely average, but it was good for us because it's just one of the first versions. Here is that presence, how person feels in virtual reality in that simulator in comparison to the real world. So basically, this is the beginning, and here we retested after a couple of months. So initial results were pretty not okay, and later we improved. It was still a spatial presence, I think, because that cabin of a truck driver was not too much realistic, but realism increased a lot, and involvement also increased a lot. So it was, we can see that we are going to the right direction, and those tools, as you can see, can really help with developing VR products. But with virtual reality, sickness, it was at the beginning completely bad. It's 50% of the people felt not good. So, so it means that when we are driving and when we get up and say, it's something not right with my hand. Yeah, so it was, and it's really a fundamental problem, because in virtual reality, when you accelerate and decelerate, it's really more complicated when you are just doing some things being on the ground. So we did a lot of research, tried virtual noses, scratches on screen, removed visual trash around the waves, and we got it lower, and I think right now we can even get even more lower, but I think 20 points is the limit. We will be somewhere here around that. So basically that's it. So as a learning tool, it was good. We had other tests, interactive web-based learning tools, interactivity test, and such. But one problem, the main problem we need to fight is that VR sickness. So that's it. I think I'm on time.
Thank you very much for your presentation. And thank you for saving time for questions.
Yes.
Okay, there were...
Okay, thank you for presentation. Wonderful. Can you please tell us more about how did you obtain that digital map? Have you created from what resources and techniques or software? Please expand on this topic.
This digital map, we used simple maps, like Google Maps or as a sketch. But when all those buildings and stuff were put here manually, and we use most of the resources are not created by us, we get it from the assets, because our point was different when to create those buildings and stuff, and we did a lot of them.
Okay, and what software do you use for modeling traffic and behavior, traffical behavior?
Traffic, we tried, we took as a basis two already existing AI traffic components.
Mm-hmm.
And one, after several months, we decided not to use anymore. And I don't remember really how it's called, but now we have something like AI city traffic or so. And it's good because we can extend them. It has source code, we extend them, we add different vehicle, different rules, and triggers when to start some situation.
Okay, thank you then. Okay.
So, thank you very much. It was very interesting. And, well, I have a particular question about the results, about
Yes.
the usability. Perhaps everybody knows that airline pilots are using very similar things, flight simulators.
Yes.
So, and you are, how to say, trying now to use similar technology, similar approach for truck drivers. How to say, what is, how to say, can we compare the usability figures and results against the flight simulators?
Oh, at the moment I don't have numbers, but I think those are really well established simulators, and especially in military training where we have those flight simulators, and it's really interesting for me how these are, especially that VR sickness with. But it's not a lot of data about it, so it's an interesting question. I think I will take a look at it later.
And maybe one very short question, which I can't not ask. Do you have virtual accidents in your virtualization?
Yes, lots of them.
I understand why they feel not so good. Okay, thank you very much for your presentation. And thank you everyone for participating in our third session, after which we will have a 15 minutes coffee break. Thank you.
say that this session that combine healthcare and technologies is arranged for the first time in this conference, and we hope that you will like that. So I am a chair of this session. My name is Olga, and I am a nurse, a nursing professor from Lithuanian University of Health Sciences. And also I have two of my colleagues that will co-chairing this session. It's Povilas Ignatavičius. He's a surgeon and professor from the Faculty of Medicine, and Rima Krikždytė. She is also a professor from Public Health, and I am from the Faculty of Nursing, so you can see very nice collaboration, not just between the professions, but also between the faculties. And also we collaborate with University of Technologies, and you will be able to hear the results of our collaboration today. So in this session we have 4 presentations. I will not go detail by each of them, but for the first one I would like to invite the presenter, Eglė Butkevičiūtė, and she will speak about, I think she will share some results from their project on some tools for drivers, and that is extremely important because in Lithuania the safety on the roads is a hot topic, and I looked to the statistic just from the last year. We have 121 persons killed on the roads and over 3,000 injured. So every effort to make the driving safer is very much important.
Thank you. Thank you, Olga. I don't need to talk about problematic right now, right? So I'm not sure where are my slides right now, because those were on. Okay, someone is taking control. Okay. Okay, great. So my name is Eglė, and today I'll try to talk about one of our projects that lead is Thomas, and he already explained a little bit about virtual master VR. So I'll talk from a bit different perspective, from biosignals, especially from PPG signals. So as for in short problematic and what we do, sometimes some accidents might occur on the road because of your fault, might occur because of other people's fault. And you need to know how to take specific decisions and to avoid those accidents, to be prepared in different situations. And even something occurs, you need to solve the problem quickly, and especially for young drivers or the newly drivers, that might be a problem. And you sometimes need to not get lost, and all the things need to be learned not in the real life environment, but most likely and hopefully in the virtual environment where you can just apply your knowledge later on the road. So effective stress management is critical for sustaining alertness and monitoring safety on the road. So as you probably saw, sometimes stress or something or fatigue might occur on the road. So Virtual Master VR project aims to create a system with truck driving situations that where real life situations are reconstructed in virtual environment for the newly drivers. We have several partners from Lithuania, that is Gluck, Vertibox, Cargo, Go, and of course Kaunas University of Technology, and the project is funded by European Union. So in short about the workflow, what we have, of course we have drivers. We need to have the real situations on the road that you just seen. We have a smartwatch. Actually, this is not a smartwatch. This is a Polar OH1 Plus device or bracelet, which is placed on a hand on specific position to gather the PPG signals. And we have cameras that collects what is happening on the road. But we do not have cameras that records what is happening in the truck itself. So we are not really sure what is performed or what does the driver itself. or maybe something else is happening in the truck. So we have PPG signals, we have accelerometer data, and we have video streams. And out of this, we want to find whether there is some correlation between specific situations or specific scenarios on the road, and together with the biological responses. So we estimate interbeat intervals and perform statistical analysis. We estimate PRV parameters and perform analysis. And out of this, we select specific situations. And later on, those situations, or at least selected situations, are reconstructed in virtual environment. So the last stage you probably already see by Thomas, where we had some simulation environment. But now move on to the pre-processing part. So huge work was done by me and all of my colleagues, where we had to annotate signals according to videos. So there were a lot of videos and different situations that we analyzed. For example, initially we started with even parking, straight, roundabout, intersection, dangerous situation, lane changing even, and many other situations. But in the end, we tried to just separate stressful parts or maybe unusual parts that the newly drivers need to learn in the end. So this is the example of the program and the labels, how it looks like, and of course the video that we need to review. So data gathering. Out of all those driving sessions, there is a lot of data, even more than 500 megabytes per hour, but you can imagine that the trips are pretty long. And in the end, we had more than 3,000 sessions, and we had to validate and select that works, that could be analyzed later in our analysis. So in the end, we had about 500 sessions that they manually labeled. We had specific requirements because, for example, we cannot perform a PRV analysis or HRV analysis because the duration is shorter than 10 minutes. The sampling rate was 135 hertz. And there were also some damaged files, maybe the radio is not saved, or with huge gaps, maybe the signals were not collected properly. Well, we had some very interesting situations that even from the video we could notice that the light diode that's supposed to be directly on your hand just flashes on the window, and basically the bracelet is worn not in the right way or upside down. So we had to filter all those data, and we left with around 100 sessions. So before making assumptions, we had to do a pre-processing part. We had to filter the data. We had to estimate interbeat intervals, and then using NeuroKit2 device, we estimated PRV parameters and performed statistical analysis. But before that, we had to normalize, all that things that usually do with signal processing. And here you can see the example of how the filtered PPG signal looked like. Well, this is just an example, and how the interbeat intervals were estimated. And according to literature and to our analysis, we found out that there are few specific HRV or PRV parameters that correspond to specific situations on the road. That metrics show significant differences in driving movements or in possible increased stress on the road. So here are some results, but before explaining the graphs, I would like to mention that we initially thought about applying machine learning techniques or deep learning techniques, but we had specific limitations at this point, so now we only perform just a statistic analysis where we have an outlier estimation with the z-score, and we just try to identify whether at least those parameters show that something is happening, or if those situations that the outliers occur actually means something in our research. So in the end, we found out that we may identify different outliers, but not all of them mean something, or at least we cannot see that maybe something else is happening in the track. So at least this one, or the biggest one, represents something that is actually happening on the road. That means that this stressful situation occurs. But on the other hand, there were some situations where, just be looking at the screen and we cannot see anything. But it might be that the driver used the phone, or it might be that it was sleepy enough and later on just wake up and something happened, But I cannot explain all the things that happened in the truck. We just try to figure out the correlation between those situations. So moving on to further limitations that we had, of course, the physical artifacts also affect the signal itself. But keep in mind that if we do a lot of movement, that actually might occur into our outliers. But in the end, if you do a lot of movement in the truck, most likely that something is happening on the road. You might have a quick turn, so that might be a stressful situation as well. And of course, we don't know the emotional state of the driver. Maybe he has a very intense call, or maybe he has a discussion that we don't aware about. And for the future analysis, we would like to explore large data sets, apply machine learning techniques, and probably one of the most important things in this project is to check whether the stress responses are similar in real life and in virtual environment. So this is what's coming next until the end of this year, and hopefully we'll find out that the stress is felt in the same way. So thank you for your attention. That's it from my side. Maybe you have a question.
So some questions? Thank you, Agla, very much. Some questions about? Povlas, maybe from medical side, we could ask something about stress, because we experience stress by ourselves, but also measure in our patients.
Yeah. Thank you for a nice presentation. My question would not maybe directed to this, your study, but do you see any other application, for example, not only for drivers, what results or this detection of a stress in other life situations? Would it be applicable anywhere else?
Thank you for the question. That is very good question, because we already have some projects that are related to the stress. That is also in training processes with medical students or nursing students. So that's applicable in almost all the fields, especially when the education comes in hand. So, thank you.
Thank you. No more questions? Okay. Thank you, Agla, indeed. So for next presentation, I am going to invite a very special person. And she is special because she is a student, master student, and practicing nurse, Evelina Stanšaitytė. And she came from Klaipėda. It's our port city, fed by size. And Evelina is working in nursing practice, and she is going to share her experience about application of virtual reality in pediatric care in the community. So Evelina, please. We are curious to listen to you.
Thank you.
So, hello, thank you for having me here. And today I would like to talk about virtual reality during wound dressings, changing, and injections among children in community nursing. It is an implementation in clinical practice. So, medical procedures can evoke fear and stress, influencing children's cooperation and long-term perception for healthcare environments. Because of that, pain management is a fundamental aspect of ethical medical practice, and healthcare professionals are responsible for reducing pain and anxiety, particularly in children. So VR interventions have been associated with the reduced distress in both patients and caregivers, highlighting its potential for widespread implementation in clinical settings. The aim is to present virtual reality implementation during wound dressing, injections in children community nursing practice. The efficacy of virtual reality in pediatric nursing is attributed to its ability to modulate pain, pain perceptions through distraction-based mechanisms. The immersive experience stimulates cognitive and sensory pathways, effectively shifting the focus away from nociceptive signals. During the procedures, children remain calmer, allowing nurses to perform medical procedures more effectively without extending the duration of intervention. Integrating VR into clinical practice helps create a positive, child-friendly environment during invasive procedures, enhancing patient comfort and reducing the stress for both patients and caregivers. So because of all that, Family Medicine Clinic in Klaipėda, my family doctor started implementation of VR equipment in clinical practice at the beginning of 2024. So the VR headsets are most commonly used for children under the age of 12, and the MetaQuest 2 standalone VR headset is used for the distraction method. In this table, you can see the technical aspects of used virtual reality headset. This technology is applied in practice by nurses who are trained to work with VR equipment and are familiar with ensuring safety. Learning to work with VR headsets involves these following aspects as safety, recharging device, fitting device, device care, controller functions, controller diagrams, starting the device, connecting to Wi-Fi, and sharing experience. In this table, you can see the procedures performed, by the nurses of various ages and work experience. Extensive knowledge of VR equipment in this application is daily. Procedures allow community nurses to use technology accurately without compromising the quality of medical procedures, and all 6 nurses, regardless of their experience in the field, was able to successfully implement VR equipment in their procedures. Just only one nurse do not use VR equipment in vaccination or wound care because her job primarily focuses on blood draws. So when the patient arrives for the medical procedure, such as blood draw, vaccination, or wound care, they are informed about the use of VR equipment in a way that it's appropriate for their age. The nurse turns on the VR equipment, sets the interaction area, and selects video contents based on child's preferences. The patient is positioned either seated or laying down in its designated space, and the VR headset is placed on their head with the straps for the comfort. If the child is older or familiar with using virtual reality headsets, they can control them themselves by the free hand. Also, you can see that what patient perceives through VR headsets in these images, since the visuals are fully immersive and block spatial awareness beyond the VR headsets, the patient is unable to see the preparation for the procedure or its progression. The patient wears VR headsets throughout the procedure or as long as they can tolerate it. It is essential to monitor the patient's overall conditions while using the VR for potential symptoms of such as nausea or loss of balance. And after the procedure, the VR headsets is removed from the patient and disinfected and stored in its designated place. A prominent issue associated with VR use remains the emergence of negative physiological symptoms, collectively referred to as virtual reality-induced symptoms and effects. These effects compass a range of bodily reactions experienced by users during or after exposure to VR environments. Such symptoms can significantly deteriorate the user's experience, limit the application of VR technologies, and pose health risks. These symptoms can manifest through a variety of symptoms, the severity of which depends on individual factors. And as you can see, these symptoms can include nausea and vomiting, eye strain, blurred vision, headache, disorientation, dizziness, general discomfort, and fatigue. And it is also very important to provide patients with parents with clear and understandable information about these VR goggles' advantages and disadvantages. So because of that, before the procedure, a medical history is collected, which includes information whether the child has previously used the VR technologies and how they felt during this experience. And if the child has experienced even one worse symptom before, VR goggles are not used. And during the procedure, the patient is monitored, and nurses ask control questions such as, how do you feel? Are you feeling dizzy? Do you feel weak? And because the monitoring the patient while using VR goggles are challenging, because the VR goggles covers a large place of the face, which may prevent medical staff from noticing the discomfort in a timely manner. And if the patient exhibits even one of those symptoms, the distraction method is immediately stopped. So all in all, the implementation of virtual reality in community nursing practice offers a promising approach. By reducing pain and anxiety, VR fosters a more positive interaction between children and nurses, ultimately changing the effectiveness of medical interventions, and continued research and development will ensure that VR becomes an integral component of pediatric nursing. So thank you for your attention.
Yeah, so thank you, Evelina, very much. Maybe some questions from the audience about this practice. Maybe it seems that nothing difficult, but still.
So we saw that you tested on something perhaps 6 nurses.
Yes.
But how many children?
It's hard to tell exact number because the implementation started at 2024 at the year beginning. So usually about 10 children per day, per working day. So a lot.
We need to use mine because maybe for online.
Hello. Like, are children more likely or less likely, or basically the same likelihood to experience nausea with the VR set than adults?
It's usually the children that gets more nauseated feeling, or even loss of balance. We had that.
Also, children are more susceptible to this?
Sorry, can you repeat?
Are children more likely to get nauseous than adults?
Sorry,
VR?
I don't have that information.
Evelina, I would like to ask about reaction of the parents. What is because I guess you need to get the permission for each case to use that. So what is their reaction before, when you just instruct them, and their reaction after?
Yeah, the parents are very curious about all the VR experiences. They are likely to accept this offer, and at the beginning we can see that, oh, I don't know, it is a little bit scary. Some sort of gadget is used, but after the procedure, when they saw that child was a little bit less afraid, a little bit less stress, yes, they are happy for that. Yeah.
Have you had any parents that tried it before the children? If
Yes, because because parents also can be afraid of the needles, and we use them for adults also if they experience any stress or fear for the needles.
Yeah, thank you. Actually, it's impressive because some time ago we have some ethical debate. Do we need to ask or permit parents to stay in the procedure room during such kind of procedures? Because anyway, we need to do those procedures, and kid starts crying and parents say, stop, stop, stop. So it was some kind of discussion, and now we have very useful tool. When parents are happy, children are happy, so it's really impressive. Thank you, Evelina, very much, and good luck in your work. So for the next presentation, I want to invite my colleagues Rima and Patrikas, just maybe come closer. And we just want to present the Lithuanian case about implementation of technologies in healthcare education, research and practice. So it will be such a little bit more combined presentation from 3 different things, but I hope that you will like it anyway.
So, a lot of, I think, 11 authors on this presentation. The main author, the main presenter is FAS, so we are divided this presentation in 3 persons. So, I will start from, of course, introduction. So, technological innovations, digitalization also is in healthcare, an important part of healthcare. So the more educated healthcare professionals are in information technologies, the higher is research levels, the easier is process of digitalization of healthcare systems. So therefore, in learning process, it is important to provide future and current healthcare professionals with the necessary IT knowledge and, of course, develop practical skills. So at the Lithuanian University of Health Sciences, students acquire both theoretical knowledge and practical skills essential for their future healthcare. The university integrates simulation technologies, virtual reality, other technologies to enhance clinical reasoning and technical skills. Technologies also enable learning and assessment process to be more flexible. Basics of information systems, databases, and data security are taught in the nursing leadership program. As I am involved in this teaching in this program and have the course about information systems, basic of information systems, so I will talk more about that. So leader is the decision maker. So what knowledge are most important in information systems and data science for a nursing leader? So nursing leader should have knowledge about information system, structure, its possibilities, and she or he also should have at least minimal knowledge about data science. So nursing leader should know, we think that he or she should know what is good system, to be able to identify the priorities of reorganization of system, be able to identify needs for system development. Also, leader should understand the importance of data security and take care of it, and also should know or should understand that important part of information system in surveillance. For example, what will be happen if, for example, after 2 or 3 years of using system, somebody decides to change codification of some features. So what will be in the system, what will be in using. So this should be understandable for nursing leaders and also, I think, for other healthcare system professionals. Also about data, what should be known about data sciences, at least minimal, basic knowledge should have. So leader should understand main data models, to be able to find data sources, be able to use data provided on open data portals, and also should understand how to visualize data. And in this course, students work with real data, with data which are on open source databases, and students use Microsoft Power BI for data visualizations. Maybe some of you already have problems with non-IT people, as there are a lot of IT specializations. So non-IT people do not understand the differences between IT specialists, such as are written here. But it is often assumed that any IT professional can repair a computer. So it is not a reality, this is not true. But a person usually understands that a cardiologist will not repair his or her teeth. So this is understandable, but in IT fields it is maybe difficult to understand. So explaining of differences between different IT specialist professions is also part of learning. And I will share my experience in working with students this year and last year. In both years, theoretical lectures and individual work are the same. Individual work is focused on evaluating information system used in their workplace and submitting proposals for reorganization. Practical work is different. So last year, students used data from WHO, statistics, Lithuanian statistics portal, Institute of Hygiene. So the data was not very closely related to nursing, so it was difficult to understand, to apply theory to practice. This year, practical work is related with real data from real hospitals, and these data are provided on the open data portal, the Lithuanian data open portal. Also, video recordings were provided for the practical work. So, as conclusion, we can say that in this year, students perform practical tasks significantly better and faster, and it is likely that videos and real data help them learn their material faster and more thoroughly. So this is my part. Next part.
So let's continue about more practical things. And of course, we speak a lot about education of our current students to be equipped with digital competencies. But in Lithuania, we have over 25,000 of nurses already in practice and over 13,000 of doctors already in practice. So we also need to think about them and to know how to develop their competencies. In practice, we are using different kind of systems, and maybe some of them are similar in other countries as well. So we have our Svidra system where we keep all the information that relates to healthcare, and access is provided for healthcare professionals and for citizens or patients or people. Also population register where we also keep all the important information. Very often we use the data from Institute of Hygiene, statistical data, also from the statistical portal, governmental statistical portal, and Eurostat or WHO databases. In practice, we also use the system for registration of patients, where you can monitor the flows of admitting patients and discharging patients. And there are some other systems for laboratory examinations, for pressure ulcer documentation system. It's nothing difficult. Mostly it's the same like what we have on the paper. We move to electronical system, some system for diagnostic examinations, surgical information system, and so on. And also, of course, to be equipped with skills to use all those systems when you are already practitioner. It's very important to start from the study phase. So we have now we're improving, really improving. We just recently opened the new simulation center in our university. So we have nursing simulations from low fidelity to now to virtual reality, and also some tools for learning to work with those systems. And also we try, as I said, to improve educational environment, to introducing different means for education using information technologies. And we have to say that in Lithuania, the software used in the healthcare sector is developed nationally, and of course systems for nursing work also are the integral part of overall healthcare. I need to switch. Yeah, and just maybe closer to look to the three of such systems that we have in our university hospital, also in other hospitals of our country. And so the first one is a hospital information system, usually where we register the patient, we register all the information, diagnostic test, medications, and different kind of that. Another one is operating room monitoring system that helps to monitor the flows of the patient, where we fix the time when patient is coming in operating room, when it's leaving it. And this system is very important for safe healthcare, because here some specific information about the patient, like some specific disease, allergies, they are recorded. So it's visible for anesthesiologists, for surgeon, for nurses. And also another system, it's national system, anesthesia registration system, where we also have information about each patient, if he or she have had some operations ever. And here also you can find some very specific information, for example, about the previous operations on nose or throat. That means that intubation should be very careful or maybe impossible at all, or there is some problem in the spinal cord, so maybe epidural analgesia is not possible. So very, very important information that sometimes patient, especially in some extra cases, patients they might not be able to report for healthcare providers. And of course now what we experience that we need much more technologies at the bedside, because now it seems that we have very good tools at institutional level, maybe national level, but we need much more tools that would help us to provide direct care to the patient. I think the same from a doctor's perspective, nurses, physical therapist or occupational therapist, and so on. So here is our future. And of course, it is important to know how those professionals who are now in practice, how they are capable to use those technologies, because we could develop very sophisticated things, but we need to be sure that those consumers will be able to use them. So we did the study 2 years ago, and this was almost the first study that measured digital technology competence among district hospital nurses and nurse assistants. We use the tool developed by Finnish researchers that was translated and adapted to Lithuanian reality. Actually, it's a very long tool having 57 items, but that is because digital technology competence is composed from several very important aspects, and all of them should be included if we want to measure overall competence. So what we found that competence in information, communication technology, in utilizing and evaluating digital technologies was rather high. And it was even higher than competence in human-centered remote counseling. So last year we started doctoral study with my student, and our aim is to develop standardized counseling for Lithuanian patients, because after COVID, this online counseling is very much popular, but it's going in a very free way. It's like simple talk, but we need really a very clear algorithm how to do that. Participants expressed the highest confidence in the ability to ensure the secure processing of customer data, especially when evaluating ethical and organizational factors. Also, it was less agreement regarding the planning and systematic implementation of digital competence development. They missed specific courses. They sometimes said that content of the existing courses is far away what we need in real practice. And some of them indicated that training was not tailored to individual needs, or this consistency was lost. Also, nurses were significantly more likely than nursing assistants to have participated in the development of digital technologies, and it's maybe understandable, and digital competence training or education provided by their workplace, and demonstrated high level of such competencies, especially in its application in the workplace. But we have increasing lack of nurses in many European countries and in the overall in the world. So nurse assistants, they need really more attention and also more inclusiveness in the care process, and the same in the use of digital technologies. And also our participants felt that both the individualized planning of digital competence development and systematic orientation for digital technologies at their work unit, there are areas that still need the improvement. And with the possibility to get the funding from Lithuanian Research Council, we developed the proposal last year and were successful together with Kaunas Technology University, and started the project on implementation of virtual reality simulation in healthcare education. we included three programs, students from three programs, nursing, medicine, and midwifery in our project. We developed or adapted two scenarios for this project, and we started to testing some stress level and other parameters. So it's just, we could say that now we are in the active phase of our project. We did 33 testing, and still we have to do more than 150. So I think that this collaboration will be already is very fruitful and will be because we try to develop a communication model prototype, implement that in education as an educational tool, analyze existing virtual reality training solutions, evaluate extended reality models effectiveness in healthcare education, and integrate this extended reality with wearable sensors like personalized feedback and optimized learning experience. So I will ask Patrikas to speak more about technical side of this project, but already can say that it really is very high interest from our participants.
Yes, so once again, at the tail end of this presentation, I will quickly go over the implementation of our specific project. So because these simulations are very conversational, it's quite essential to integrate an artificial intelligence-based solution. If a student is talking to, for example, a patient, a nurse, a doctor, it is important for that second party to have context of the conversation, to respond correctly, and so on. But this can be quite a challenge because we are trying to educate healthcare professionals, so the data is quite sensitive. It's important to be correct and to minimize artificial intelligence hallucinations. In addition, one of the challenges was that we have to perform this in Lithuanian. So Lithuanian text-to-speech, speech-to-text is a challenge in and of itself. So to solve these challenges, we created a three-stage interaction pipeline of speech-to-text, then AI processing, and then finally text-to-speech. So in this little diagram here, I've tried to present the process and how it goes from start to finish. So first, the user enters a voice prompt, which generates text locally using OpenAI Whisper. Then the generated text gets processed, and it creates a request that gets sent to the OpenAI API. This generated text is then analyzed, and another request is sent to generate the speech, which is then played along with lip sync. So you might think that this is very complicated, especially because OpenAI offers a real-time API. However, this allows us to solve several challenges. So for example, as I've mentioned, it's important that the data is correct. And so this allows us to check the data before we actually send it out as a voice reply. This allows us to have local integration of the system. So Whisper is run locally, and we're hoping that in the future we can generate text locally as well. Furthermore, this allows for independent parts of the systems. So if, for example, 11 Labs creates a better text-to-speech model, we can quickly switch it out because we are not locked down to one specific provider. And finally, this allows us to track and monitor the whole simulation, which is more difficult with a real-time solution. So as Olga has already mentioned, we have began testing. The first round is already complete with around 33 students. Here are some pictures. And finally, for the conclusions, at Lithuanian University of Health Sciences, the future of healthcare education will evolve with the integration of AI, intelligent learning analytics, and remote surgical observation platforms. The integration of various electronic health systems at Lithuania's leading healthcare institution significantly enhances workflow efficiency, patient safety, and data management for healthcare professionals. And finally, as technology continues to influence healthcare training, interdisciplinary collaborations and cutting-edge innovations will ensure future professionals are well equipped to meet the demands of modern clinical practice. So once again, some pictures of our project. Thank you for listening to this 3-part presentation, and we are now awaiting your questions.
So please.
Perhaps from the technical
Patrick is
integration.
ready to answer technical questions.
I will bring you a microphone, yes.
Thanks. How long is the delay between the, because it's a 3-part process,
Yes.
how long is the delay for generating a response?
So because it is a 3-part process, there is quite a delay. It is about a second, though it depends on the internet connectivity. For the future, we are planning to try to use local caching to reduce that delay. We did experiment with a real-time solution. However, sometimes the nurse might start speaking Spanish or simply cut off. It was a lot less stable. So even though there is a delay of about a second, it is still more realistic than having the issues of real-time.
Yeah. Well, my second question was, what have you tried to mitigate it? You already answered. Thank you.
Okay. Thank you for the question.
Something else to ask? Thank you. Thank you. For presentation.
Last one?
Yeah, last one. Yeah. Filippo?
Oh,
yeah.
okay.
Yeah, the last one. We are allowed a little bit to use more time from conference organizers.
Nice.
Yeah. Okay, so Filippo, I think that some people already met you, and actually I don't know a lot about you to introduce you, but I hope that you will tell everything.
Yes, I'll
what
try
we
my
need.
best. And more than introducing myself,
Yes, please.
I would like to introduce my co-authors first. So this is a work with Patrick, Sugne, and Thomas. And it's a part of an ongoing project. I will tell you more details about the project itself. The title is Structuring Immersion Levels in the Reality-Virtuality Continuum, a multi-sensor approach. So during this session especially we have heard about virtual reality, augmented reality, and I think that this talk now fits very well. And this slide kind of summarizes all the spectrum that we have from on the left side, we have the real environment, so the real world, and all the way to the right side, we have the virtual reality, so the most immersive solutions are on the right side. And in between these two extremes, we have multiple solutions. So for example, if we are closer to the left side, we have augmented reality. It means that what we see is the real world, but we augment. We add on top of the real world another layer with synthetic elements. If we go towards the right, we have augmented virtuality, which means that we see a virtual world, but we add elements from the reality. So for example, we can see a real person inside the simulator. So as you can see, we have a quite wide spectrum, and with solutions that depends on the applications that we are considering. And this is already an established framework, but most of the time, actually, this spectrum only focuses on visual feedback, so what we see. But humans actually have 5 senses, right? We have the sense of touch, we have the sense of smell, the sense of taste, and hearing as well. We can hear sounds. So we have 5 senses. So the idea behind this work is basically to expand this established framework into the remaining senses that humans use. And this is the table that summarizes this concept. So especially for vision, I would say again, this is an established framework, and vision in the last 100 years has seen a revolution, right? So from the first, camera that was on film and black and white, we have seen today we have cameras in our phone with amazing resolution, and we can capture photos and reproduce photos. The same has happened, for example, I see some from my generation in the 90s, Sony released the Walkman. So it was the first time that people in their pocket could have a device to record music and reproduce music. And what we see now, something similar is happening with touch. So for the first time in the last few years, we are developing devices that can actually record touch. So imagine that you could record the hug of your mom when you were a child, a kid, or maybe a handshake of a famous person, maybe Obama handshake, and then reproduce it. After some time, you can reproduce it. For audio and video, actually, you can Shazam songs, right? There are apps that you can use to automatically, obviously with the use of AI, to detect a specific song. With pictures and videos, you have YouTube, we can Google pictures. Imagine in a few years to be able to Google touch experiences. As I said, maybe the handshake of a famous person, and reproduce it. With smell and taste, this is also happening, but of course the technology here is a little bit more complicated and also more invasive. So, for example, reproducing taste also requires the implant of needles on the tongue. But there are now state-of-the-art works that can reproduce a low-resolution taste, like, for example, sweet or salty experiences. So this is happening, and we have, in the paper that we have written together, we have tried to categorize this in a structured manner. And as an application, I would like to introduce you with the project that is called Beyond the Classroom: Virtual Reality, Augmented Reality, and Haptics for Enhanced Surgical Training and Education, Immersive Surgical Aid. So this is the website that you can visit. The project is reaching the end, so you can already see a lot of materials that have been produced. And this is a collaboration between the University of Agder, KTU, the University of Siena, and the Lithuanian University of Health and Science. Here we have colleagues. And what I would like to show you is a possible application of this idea of using touch for training purposes. So probably in the interest of time, I will actually explain this orally. So here we have a hospital simulator, and on the left side there is a surgical doctor that is going to perform palpation on the abdominal area as a training session for the student that is on the right side. And the doctor is wearing a wearable device that we have designed, and it's actually like a recorder, like an audio recorder you would have, but this is actually recording touch. So what the doctor is touching, we are recording this tactile experience into a song, or like an MP3, you could say, where we store this tactile information, the forces that we are recording, and then we transfer this wirelessly to the device that the student is wearing, that you could see here. So this device is playing the song, is actuating the fingers and simulating the forces, like squeezing the fingertips so that the student can feel the same tactile experience that the doctor is simulating, is performing. So, and we know that for training, especially for medical training, tactile experience is very, very important. And of course, most traditionally, this kind of training is performed with real patients or with cadavers, which is not very easy to replicate on a large class of students. So what we think is, by using this technology, we can train students in a much more scalable way and more sustainable. I'll give you some more details about this technology. So the rendering device, the device that plays the song, is actually already a commercial product which is developed in Italy by one of our partners, WeArt. So the rendering device can reproduce forces, they can reproduce texture and also temperature. So you can feel, for example, if I'm touching this cold water, you can feel the temperature of the material that you are grasping. We have designed the other device, that is the one that records the experience. Here we have summarized this palpation procedure that is performed by the doctor. And here is the integration with the Unity simulator through the middleware that is provided by the VART device. And here is a little bit more technical. It's about how to simulate the touch of an object that is not there, right? We are in a simulated world. The object there is no physical object. So what we do is we use this method that is called proxy finger. And you can see here, the idea is very simple. If I would press my hand against the wall, there would be a reaction force for the Newton's law, right? That is going to be equal and opposite to the force that I am applying. So the idea here is to simulate this by allowing a virtual hand, like a ghost hand, to penetrate the object, the visual object. And that distance is going to, and the velocity of penetration is going to give us the force by applying the second Newton's law. So it's a very simple idea. So the force will be proportional to the distance and the velocity of penetration. And we assume, obviously, that the mass of the hand is known. So here is the idea. So you see two hands here, the yellow and the red hand. One is going inside the human body, and the green vector that you see, that's the model of the force. So we also added some audio feedback that helps kind of visualizing that operation. And here is like, okay, for songs we have MP3 formats and other formats. So we came up with a format to store touch, right? So we used initially just a text file, but then we switched to JSON files. So these are just standard protocols to store informations. And sometimes, the idea came from an evening at a karaoke bar. Karaoke songs are stored on a MIDI file where you have all instruments and on a timeline. The same idea is here, like you have instruments are fingers here. We have 3 fingers, and for each finger we store the position, the rotation, and the force. And here is like the view of the simulator. Initially, you can see there is an interface where you can calibrate the sensors and you can set some thresholds. And then here we can visualize the trajectory that the doctor has performed in space, and then the other line is the trajectory that the student has performed by trying to mimic what the doctor did. And we can also associate some matrix to give a score, like points, collect points, like 74.81%. That was the score that the student has achieved in this specific procedure. So we can grade, we can kind of assess how good was the student in performing or replicating the procedure from the doctor. And here we can see the same visualization but in space. So you can actually see where the doctor was touching, and you can see the module of the forces that was applied. So you have an interface for the teacher and an interface for the student. And then we have done our first trial with 13 students. So we had the doctor recording the procedure and then 13 students replicating it. And we have then, at the end of each session, we were giving the students some questionnaires to answer and report about their experience. So here we have some results, and most of our results seem to be promising. So this is the as a CIQ chart, and it will show us the quality of interaction, comfort, performance, consistency, and sensory enhancement. And then we have also used some other matrix like the IPQ chart, and generally we have, let's say, promising results, but there is room for improvement in terms of realism and involvement. The same here. Most of the things are promising, but some of them are borderline. This was really the first trial, so it's motivating, but also we have something to learn from, and we are trying to improve some of these results. So, for example, one way to improve the experience, if you have seen the previous video, we were only simulating the upper layer of the tissue. Organs were not simulated. So when you press against the abdominal surface, you don't actually have a realistic feeling from a medical perspective. The idea would be to integrate organs below the layer of the tissue. And also, as a future work, we are considering experimenting with new rendering devices, like these ones that you can see in the picture. So this was my last slide. I'll be happy to answer your questions.
Thank you very much. It's very impressive. I guess students like such kind of education much more than just on simple mannequins or learning from books or even in anatomy room. Yeah, nice. Yes, please.
Yeah, okay, thank you for presentation. Wonderful again. Yeah, okay, so, but it seems to me that only if you are, let's say, using only the fingers, but you know, the posture also makes sense, you know, when you're touching, so your brain not only senses the fingertips, but only the joints angle, you know, how you apply the whole arm or maybe other body position, you know, so it's not just touching, so maybe you also could apply maybe future more sensors, you know, on the arms maybe, to feel how you have to push it, you know, the posture, you know. And another thing, you should also think about maybe, you know, we having the whole palm can be a sensor. Okay, so you maybe try to also investigate the position of applying the whole glove, you know, not just fingertips. No, I know that they are just most sensitive, but the whole let's say glove can be maybe applied.
Definitely. Yes. So I think that these are very good points, and again, this is an initial study. But for example, some limitations here are these rendering rings can only actually simulate the module of the force, not the direction. So you know, a vector in space has a module and a direction. So this is somehow kind of improved experience through the overlapping with the visual part, right? So if you also see, then your brain will kind of be a little bit triggered to understand the movement, the direction of the movement. But another way, for example, you mentioned the palm. These other devices, for example, this one also include an actuator on the palm and a sensor. This one, you see, the more you add, like here you have all the fingers with the actuators and the palm. Here is a little bit more because there are other sensors. And of course, after this device, there are other devices that can also give you the direction. These are exoskeletons. But you know, it's a trade-off. It's always a trade-off, right? The more you add on the hand, the more you also kind of limit the movements, right? So it's a trade-off there.
And you can have a few versions, you know, if you want to go deeper, you can have that skeleton on and have that experience.
And there are even like suits, like exoskeleton suits, where you can also have you can have sensors and actuators on the arms, the legs. Yeah. So there is a way to do it, but it's a compromise. And in this project, we wanted to also make it low cost. And so, for example, we have one device that we have designed. It's on a GitHub repository, and it can be downloaded by the student. They can 3D print the parts, and they can make it at home. Yeah. With just a few motors and sensors.
Will you provide the link?
Yes, I can provide the link. I can talk to you.
Okay.
Probably. I'll talk to you later. If you Google Simple Timple, it's a repository with a page with all the instructions step by step.
Thank you. Thank you.
Yeah, thank you. Thank you very much. For your participation, and I'm sure that now we deserve very tasty lunch. So
yes, but before I would like to say very big thank you for your contribution to chairing session for Professor Olga Riklikiene.
thank you.
So thank you very much. For Professor Rima Krejzdite, thank you very much. And for Professor Povilas Ignatarius. Thank you very much. And now we'll have lunch, and I would like to ask you to stay here at least before this paper works and conference closing ceremony, because it is quite a predictable article, yeah. So we would like to see all of you right here, and after 6 p.m. we will have gala dinner right here. So all of you are very welcome. So, and now I would like to ask you for lunch.
You think it's still here or not?
Yeah. Cybersecurity sessions, special session on cybersecurity chaired by Professor Dr. Šarūnas Grigaliūnas, who is the main, I think, the best in general. Yeah. Yeah, the best. Yeah, Liemkes. And so what? So I would like to give Grigaliūnas. So.
Okay. Loud and clear. Okay. So, good morning, good evening, good afternoon, depends on your time zone. I'm very appreciated that you involved me, to this special cybersecurity session, and it is very pleasure to announce that we at least twice increase from last year presenter. So it means that it seems this field very important for everyone, and. I would like to introduce first our speaker, Edgaras Baranauskas, who is as well a friend of mine in the very technical field, which is energy sector. Please give applause to the Edgaras, and Edgaras, start with your topic right now. 12 minutes and 3 minutes for the questions, so that's our window.
Okay, thank you. So, good afternoon, everyone. My name is Edgaras Baranauskas, as Šarūnas represent me, and today I will be presenting a quantitative security framework for evaluating cyber resilience and energy efficiency of Internet of Things message queuing telemetry protocol. Efficiency of Internet of Things. This research explores how to balance two often conflicting goals in Internet of Things systems, security and energy efficiency. So the message queuing telemetry
Should the slides change?
It's not changing?
No.
Yeah, because it's here it's changing.
See? Sutvarkysim, pasižiūrėsim. Čia turėtų būti varnelė tos. Tuos ras. Ir pilnai viskas veikia.
Ne, tą paspausti nėra.
Va, čia, darykim tai. Taip, darykim tai dabar. Okay, now it's working.
Okay.
Čia yra šitie komentarai.
Okay.
Okay.
Now it seems working.
Back on stage.
Yeah, back on stage. So the message queuing telemetry Transport Protocol is one of the most widely used Internet of Things communication standards, especially because it's simply and lightweight, perfect for low-power devices. But however, this protocol does not include built-in security mechanisms, so developers usually add transport layer security encryption to this protocol. This leads to trade-offs. Transport layer security increases security, but it also consumes more energy, reducing battery life. In addition, message queuing telemetry transport offers free quality of service levels that influence reliability and energy usage. Our challenge was to quantify these trade-offs and provide that data-driven guidance instead of relying on intuition. So we structured our research into four main contributions. Novel metrics, so we introduced two quantitative metrics, energy efficiency index and security energy cost ratio. Second, integrated methodology, a structured approach combined quality of service levels and transport layer security encryption. The third, real-world testbed built on SP32 device communication with Mosquito message queuing telemetry transport broker. Actionable findings identify the optimal trade-off points using Pareto frontier analysis. This framework evaluates Internet of Things communication across 4 dimensions. The security dimension comparing transport layer security encrypted and unencrypted communications. The reliability dimension testing all 3 quality of service levels. The data transfer dimension observing actual message behavior. And energy profiling where precisely measure voltage depletion over time. By combining these dimensions, we can evaluate both energy and security in an unified quantitative way. So the first metric, the energy efficiency index, measures how much voltage the device loses per hours of operations. It's calculated as a difference between the initial and final voltage divided by operations times. Lower energy efficiency index means better energy efficiency. The device consumes less energy and lasts longer on battery. This gives us an objective way to compare how different quality of service and encryption settings affect power usage. The second metric integrates the second metric, security energy cost ratio, integrates both security robustness and energy consumption. It multiplies the quality of service factor and encryption factor and divided them by energy efficiency index. The results tell us how much security per energy cost we can get from each configuration. The higher the security energy cost ratio means a better balance, stronger security for reasonable energy expenses. This helps identify optimal setups depending on application priorities. To validate approach, we built a real-world testbed with the controller SP32 as the Internet of Things device, with Raspberry Pi as the MQTT broker running Mosquito, and the multimeter to measure voltage precisely. We tested 6 configuration free quality of service levels with and without the encryption. So the transport layer security was configured on the port 8883 using the certificates for authentication. We verified encryption using Wireshark, confirming that packets were encrypted and unreadable. The Mosquito logs confirmed the quality of service operation, especially quality of service 2, which provides exactly once delivery. This ensures our security analysis was based on the real cryptographic protection, not configuration assumptions. So our experiment covered 6 scenarios, quality of service 0, 1, and 2 levels, both with and without encryption. Each ran under identical conditions for 3.5, almost 4 hours. Voltage was recorded continuously and energy used was normalized to volts per hour. This allows precisely calculate the energy efficiency index and security for each configuration. Here we can see the measured voltage drops among all transport layer encrypted configuration, quality of service levels with quality of service level 1 with transport layer security achieves the lowest energy efficiency index, meaning it was the most efficient secure option. Quality of service level 0 used slightly less energy overall but lacked reliability, while quality of service level 2 consumed more due to extra acknowledgements. When we compute a security energy cost ratio using encryption factoring of 1.5 for transport layer security, the values were like this. So while quality of service 2 consumes more energy, it delivers the highest security and reliability per energy cost. Quality of service level was the best balance for greater Internet of Things usage. We will visualized all configuration on Pareto frontier. 3 optional points emerge: minimum energy, quality of service level 0 without TLS, good for non-critical sensors, balance trade-off with quality of service 1 with encryption, ideal for typical Internet of Things deployments, and the maximum security, quality of service 2 with transport layer security, suited for critical infrastructure. So this graph clearly shows how to choose configuration based on use case priorities. When they mapped the results to real application, environmental monitoring, quality of service 0 with no transport layer security, prioritized energy, smart homes or industrial controls, quality of service 1 with transport layer security, balance reliability and security, and for medical or critical infrastructure, quality of service 2 with transport layer security, maximize security. So this demonstrates that the framework supports the scenario-specific optionist, non-one-size-fits-all approaches. Observed several important patterns: higher quality of service level, increase energy use, do more acknowledgements. Transport layer security adds encryption overhead, especially with complex ciphers. Quality of service 1 was sweet spot under encryption, offering the best efficiency security balance. Security energy cost ratio provides an objective quantitative way to compare these trade-offs. Even though experiment focused on message queuing telemetry transport protocol, the framework is protocol agnostic. We can adapt those energy efficiency index and security energy cost ratio to other kind Internet of Things protocols like COIP, XMPP by recalibrating factors for their security and reliability models. This makes the approach applicable to a wide range of Internet of Things ecosystems and future communication standards. To conclude, in this research we proposed a quantitative framework for evaluating the trade-off between security energy in Internet of Things systems. We introduced 2 universal metrics: energy efficiency index and security energy cost ratio. Validated them experimentally. Quality of service 1 with transport layer security provides the best balance, while quality of service 2 with transport layer security offered maximum security. These results empower developers to make data-driven design choices, improving both cyber resilience and sustainability. So here's the future works. It could be compared in large-scale deployments, lightweight security, adaptive configuration, protocols, expansions. So thank you for your attention, and I'll be happy to take any questions.
Do we have any questions?
Do we have time for them?
No.
At least 1 minute we still have.
So thank you very much. It was very interesting, and I guess you were curious enough just to test, and maybe you can give some approximate results extrapolated to those another protocols mentioned. So you made a deep study on MQTT, and
Yes.
well, but you mentioned some other protocols. So what are your expectations about them?
I think the results could be the same if those protocols would have the same quality of service levels. So that's my opinion.
If all right. So thank you,
Edgaras, and we will continue with the next hour speakers. I have notified that we still do not have online speakers, do we? Any? No. Right, so then we will make some changes in our line. Sorry? Yeah, but do we have online any? No. So let's do the change, and we invite Linus to present these to make a presentation based on the privacy and security focused system for the customer data management in e-commerce. And then we will continue with the online team later on.
O šitas jo. F5. Nu, šiaip turėtų F5, bet arba metu. Na gerai, jeigu svarbu rodo, tai gerai. Okay, so I can begin. Yeah. So I have already been presented, so just to save the time, I won't repeat who I am, and the topic of the presentation also is on screen, so you probably read that already. So what's the big idea? So currently we have legal privacy frameworks in European Union and also in other countries, but our work is focused on European Union. And basically storing some kind of sensitive data in your own systems currently requires either added security on your part, or you would probably prefer to not store sensitive data on your systems. We are focused on the domain of e-commerce, and basically we are offering a method that allows minimization of storing of personally identifiable data in e-commerce systems. This is the presentation of how that might be done. So the basic idea is that in the domain of e-commerce, we only have two types of actors. One type is service provider, which means any kind of participant of e-commerce that is providing services to the end users or to the other participants of e-commerce, for example, a merchant, a logistics provider, and so on. And the other type of actor is a mediator. This is the actor that we are proposing, and mediator is the party that is responsible for storing sensitive data of service providers on its own systems, and on the systems of service providers, that sensitive data is substituted by synthetic substitutes that are, for example, in case of name, address, phone, or email, totally realistic, but they are not connected to the authentic values. And in this case, if we are working with these synthetic substitutes on the side of service provider, then as long as we are doing that, we are not risking any exposure of sensitive information, because these substitutes are basically not connected to real people in any reversible way, and we avoid problems with that. So how it works? First, a service provider must enroll with the mediator system. So the basic idea is that the service provider generates a symmetric key share for itself, and then it basically extracts all the sensitive attributes from its own database related to all the customers, for example, and sends those attributes and the key share to the mediator. The mediator also generates a symmetric key share relative to that service provider. So the encryption on the mediator side is by using these combined key shares. And then it encrypts everything that the service provider gave to it and stores on its own system. And also, while it is doing that, it generates synthetic substitutes for the authentic values that we sent by the type of the value. So obviously, we have to identify what we are sending and sends those synthetic substitutes back to the service provider. And the service provider then replaces the authentic values by the substitutes and lives on with less risk of personal data exposure. Now, inside the mediator system, all the cryptographic operations go through what is called a secure cryptographic environment. And basically, this is a system that must be extremely protected, and it does all the cryptographic stuff. So all the encryption operations of any data that is coming, and key manipulation operations and decryption operations are happening in there, or the re-encryption operations in another way. And obviously, in our case, this is a central point of failure, the way that we are doing it. If this is compromised, everything gets compromised. But on the other hand, it allows a little bit simpler implementation, and a little bit less expansion of the data when you are storing it in encrypted form. Let's probably skip the slide. We will return back later. So obviously, if we have real-world systems in the domain of e-commerce, you cannot use substitute failures everywhere. There eventually comes a time, for example, when you need to write some kind of receipt or some kind of invoice, and you have to use real values there, because otherwise you would produce an invalid document. So in these cases, the service provider system must request the authentic values back, and that is done by using basically cryptographically signed contracts that are attached to the request to retrieve some set of authentic values, and that contract is validated. The authenticity of service provider is checked, and if everything is okay, we log the request, the contract, and send back the values to the service provider. And service provider is supposed to only use those values when it gets them, and if they are no longer necessary, then throw them out. And if they go into some kind, for example, document that saves them, then that document must go into some kind of secure storage on the service provider's side to ensure additional protection. Also, we can update authentic values on the mediator side. Basically, we just send new values and re-encrypt them and send back either the new substitutes or leave the old substitutes. Sorry, what I was showing here. Oh, that was retrieval, that was the obfuscation. And we can also exchange user data between different service providers, meaning that if, for example, user data is stored in a service provider that does e-shops, and we want to set that data to service provider that does some kind of logistics. If we are both signed on to the mediator system, we have a workflow, a process which allows us to transfer customer data from from a domain of one service provider to the domain of other service provider by using the protocol that is described in here. So basically, we send the key shares of both service providers to the mediator. It does the data exchange, transfers the data to the domain of new service provider, also generates the obfuscated values, the substitute values, and in this way, new data comes to the domain of new service provider, and it can start using it. Okay, so currently we are doing the experimental stage of this method. Before that, we have done analysis of potential impact, how it would go on business decision support, and we have used what's called a TPC-DS benchmark for that. That benchmark contains standardized queries that are related to processing of business information, whereas 47 queries related to customer data. So it came out that out of those queries, only 5 queries cannot be done without involving deobfuscation, meaning retrieving of the authentic data back from the mediator to the service provider. And that is happening because those queries involve some kind of real-world locations or timeframes, and we just have to connect them to real-world data of a customer. Other 42 queries can be done with obfuscated data, which sort of indicates that this approach might be workable. Okay, so in conclusion, our approach is meant to improve increased privacy and security for the customer and stronger compliance with customer data protections regulations for service provider. Additional advantage is that it should be retrofittable onto existing systems because we are not because those substitute values that we are passing back to the service provider, they are usable with legacy systems. As long as we can work with obfuscated data, and if we are also adding this approach to systems, that sort of naturally requires partitioning those systems into insecure and secure domains, because the authentic values must be only accessible in secure environments, and that also sort of forces additional layer of security due to how the system has to be designed. So that is all. I am aware that I messed up the explanation of a few slides, so if you did not understand what was in there, please ask. And probably that's all from me today.
Thank you, Linas. Do we have questions from the audience?
Thank you for the presentation. Is it working? Yeah? Okay. So my question is, you are mentioning the attributes of the customer data. Mm-hmm. So which of these you are considering as sensitive, and which of these you are encrypting?
So basically, in European Union, any kind of attribute that is connectable to real identity of a customer is considered sensitive because of GDPR regulations. In terms of our system, basically service provider can send whatever we want. Obviously, we must support some kind of taxonomy because we have to generate the substitute values that are believable in terms of original values. So we must know if this is name, surname, address, or something else. Yeah, as far as mediator does, it does not matter very much, and as far as merchant does, we probably want to store everything that goes under GDPR regulation.
Do you have any question to Linas? Right, so thank you, Linas.
Thank you.
It was, yeah, very nice to see you here. And yeah, let's move to the another topic. Hello, are you hear me? Okay, I see.
Hello?
Oh yeah, oh yeah. So yeah. So let me introduce next our speaker, which is Kyriaki Santikidou. All right,
Yes.
sorry from the pronouncement.
No, it's okay.
Yeah, she will share with us a topic which is a cybersecurity certification-based program for hardware security systems. So, yeah, please, floor is yours, and I hope you will able to share your slides as well.
Yes, give me a moment. So,
Are you able to share the slides?
yes, I'm sorry. Yes.
Take your time, no rush.
Okay.
So,
Can you see my screen?
Yes, and please try to fit in 12 minutes and 3 minutes for the questions.
Okay. Okay, so can I start now?
Yes, please.
Okay. So hello, my name is Kyriaki Tsadikidou. I'm associated with Sketali Group and a PhD candidate in the Computer Engineering and Informatics Department in the University of Patras. And today I'm going to present to you our paper, Cybersecurity Certification-Based Program for Hardware Security Systems. So IoT and hardware security engineering is extremely important in nowadays because real-world applications more and more adopt novel technologies such as Internet of Things that overall have limited resource-limited devices and systems integrated into their systems. So especially in order to prepare engineers to handle real-world applications, this type of real-world applications, this hardware security must be integrated into STEM education, which is extremely difficult as not a lot of programs exist that go in depth regarding these topics or are either specialized in hardware security. So as a solution, we propose a cybersecurity program that is based on certification, on existing certification programs and is targeted for the university education curriculum. So first of all, we're going to introduce some existing certification frameworks and certification programs. So what is a cybersecurity certification framework? It overall specifies the methods for two things. First of all, in order to properly educate and train the participants, how to educate and train the participants. And second, how to ensure the integrity of the certification program. So there are two frameworks currently in literature. The first is the ICIST Cybersecurity Certification Framework that certifies products, services, and processes and builds trust regarding all those regarding products. And the ISO IEC framework that instead of certifying products, creates certifications for certifying persons and participants. So what is a certification program? A certification program overall equips beginners or professionals regarding a specific or a vast subject and giving them the appropriate knowledge and skills about this subject. So now we're going to discuss some existing certification programs, and we're going to see which of them discuss hardware oriented security and how they handle this type of topics. Because our program wants to focus on this. We want to overall introduce a specialized type of program. So the NIST Cybersecurity Framework 2.0 Lead Implementer certification qualifies participants regarding management, monitoring, and implementation of the NIST Cybersecurity Framework, which is a framework that overall gives organizations the appropriate skills and tools to secure their application. Its purpose overall is giving the mechanisms to participants to secure and to manage system security and with cybersecurity policies and planning mechanisms. And it is for entry level and expert level. Another framework is the Certified Information Systems Security Professional. That has a lot of topics, including IoT, industrial control system, and hardware cryptanalytic attacks, such as side channel attacks, which is the topic that we also want to focus on. But in this framework, a lot more topics are also being included, such as software development security tools, application security testing, and overall it is for only experienced candidates. Another program that is a follow-up course of the previous mentioned course expands on the previous mentioned topics. IoT includes SCADA, verification and validation, and overall includes also the topic of physical security requirements for infrastructure security in an infrastructure architecture, which is also important. But once again, we have a lot of topics regarding threat modeling and simulation, for example, and cryptographic solutions, and a lot of more expands more on those topics. So the Computing Technology Industry Association has 3 certifications. The first certification, the Security Plus, includes hybrid environments and how to respond to those type of threats and cyber attacks, and overall gives the participants the tools to manage vulnerabilities for both hardware, software, and data handling. The Security X also includes hybrid environments and specifically networks, and how to implement them, implement the security solutions in those types of applications, and also includes endpoint security control. So as we can see in these 2 frameworks, we have once again a vast variety of topics, and that also includes hardware and software and network handling. The next framework is the Pentest Plus, that focuses on a more specific topic, which is penetration testing and how to recognize and exploit vulnerabilities and in physical layers. And so overall, we want to focus more on those types of programs that have a specialized topic. So another program is the Global Industrial Cybersecurity Professional Certification. That, as we can see, has as a topic focuses on the industrial control systems and how to manage the assets, their functions, and overall their endpoint security. Once again, it has it provides basic knowledge regarding protocols and technologies. But we also want to include more specialized and in-depth knowledge. So the certified cybersecurity technician targets entry-level participants and focuses on information security. Once again, we have, because it is an entry-level certification, we have a basic knowledge and skills are provided. And the Certified Application Security Engineer is another certification from this same organization that focuses on software professionals in this case. And even though it focuses on IoT devices, which is the topic that we also want, it mostly focuses on the software development lifecycle of these types of applications. The last one that we're going to discuss today is the Certified Network Defender, which focuses on the which targets system administrators. And overall, its topics focuses more on the network security of things and protecting endpoints, data, and network. Once again, we do not have a specialized framework that we think that it's most important in order to properly equip the engineers in the nowadays applications. So our proposed certification-based program overall provides a STEM-based specialization, meaning that it covers the hardware security, IoT components, and hardware dedicated components through various aspects in order to completely cover all of these topics. And overall, in order to be a valid certification, it follows common certification programs and how they are structured and how they provide their necessary information and skills in order to have an integrity. So the topics that this program is focusing on, and these specific topics are IoT device security, secure hardware design, firmware protection, end-to-end secure communication, meaning that from an endpoint to another endpoint through a IoT-based application, how and which mechanisms are employed, cryptography mechanisms are employed in order to secure either data, hardware, or hardware. So another topic is the hardware tampering or analysis attacks. So this topic was the most employed topic in other certifications that we saw. And we also want to expand on this topic. And the hardware implementation of cybersecurity mechanisms. So this means that instead of only providing information, we also want to include hands-on training and how to implement these types of mechanisms in order for engineers to be able to efficiently correspond to real-world applications and for them to transition to industry, for example, more efficiently. So the target groups are undergraduate and graduate university students, and this in order to adjust the curriculum, to provide the more adjusted curriculums and hands-on training, 3 different levels of expertise are provided: the beginner level, the intermediate level, and the advanced level. As we can see here, all levels are interconnected to each other, so the one builds upon the previous one. So the beginner level provides a theoretical course about cybersecurity, meaning that it provides the basic terminology and a basic awareness regarding cybersecurity and IoT-based structures. Yes. So this means that because it focuses on this type of structures, only this type of terminology is going to be provided. With also common cybersecurity frameworks are also going to be mentioned, for example, in this CSF 2.0. So the focus of this level is for the participant to be able to correspond with appropriate cybersecurity strategies and mechanisms that are hardware oriented without overstimulating the participant with multiple themes regarding the applications IoT and real world applications. So for the next level, the intermediate level, more in-depth knowledge is going to be provided with more cybersecurity standards and cryptographic mechanisms being included in the curriculum. For example, recent standardized cryptographic mechanisms such as the NIST lightweight cryptography, NIST privacy enhancing cryptography frameworks are going to be included, and for them to try to implement them, because in this level, hands-on training is going to be more crucial and more important in order for them to be able to handle real-world cybersecurity problems. And overall, they're going to be a dedicated system for them to expand on their creativity and implement these mechanisms into IoT devices and systems. The advanced level Once again, is a follow-up level that overall allows students to participants to study the current literature and to have them analyze and possibly implement a lot of optimizations that are proposed by literature, either hardware and security optimizations. And overall, another interesting part of this level is for them to be able to adapt a more general frameworks for more general applications into IoT and hardware-based systems, always taking into consideration the specific requirements and limitations of this type of systems. Once again, we have a hands-on training and so more open source problems are going to be discussed, and always encouraging creativity and allowing them to implement flexible mechanisms. So the requirements in order for the certificate program to be valid are the following. First of all, because it is a university course type of course, multiple lectures in one semester are going to be implemented with special training lectures and lab projects, which are peer-reviewed. So for the beginner level, 1 or 2 special training lectures and a final last project is going to be included. And for the intermediate and advanced levels, more frequent trainings and projects are going to be included into the curriculum. Of course, a specialized test, as all type of certification programs, is going to be included at the end of all courses. So in order to keep up with new standards, yearly revisions and updates are going to be included. And also in order to evaluate and advance the programs, we're going to take into consideration surveys, assessments, and the project's performance metrics. So as conclusion and future direction, this work overall proposed a cybersecurity certification-based program that analyzes hardware security and IoT systems. By analyzing cybersecurity certification framework and programs, it tries to overall provide an integrity into its program and how to properly function as a certification, and provides 3 levels of expertise in order to properly equip both beginners and professionals with the appropriate knowledge. And it aims to bridge overall the gap between education and industry. As I said before, we try to provide the necessary tools to participants in order for them to handle real-world applications and promote a problem-solving mindset. As a future direction, we would like to do a pilot program in universities. So thank you very much for being wise in from which this publication was built upon. And thank you very much for your attention. If you have any questions, I'm very pleased to answer.
Thank you for your presentation. Do we have questions in the audience? Yeah, we have one.
Thank you very much. First of all, my best wishes to Valeria and Nicholas, because I know them personally. So my question is regarding the validation of your proposed cybersecurity framework. Have you done it? How you did it, and as well how it fits to the reality? So it means that how well it fits to the gaps which are missing in existing cybersecurity frameworks.
Mm-hmm. Okay, so this is only a first start project, so this is at the beginning. So we considered a lot of real existing certification programs in order to overall propose this type of course. So it is at the beginning of its board, at the beginnings. So we would like the gaps that are overall being fulfilled is a lot of certification programs overall have a more basic kind of knowledge and skills that they provide. So they overall give you a lot of mechanisms that if that happens, you have to do this, and they do not test their participants and provide them with a hands-on experience regarding these topics. So what we want to do is have a more specialized program. So not only provide participants with a vast and a lot of information. We want to give them information regarding this hardware oriented security domain, and then by providing all this knowledge we want to also see them implement them either by code, either by coding devices or systems, or whatever their preferred method of testing will be. So I think I answered all your questions. Let me add, for example, that because this is a beginning type of research, as for future direction, we also want to see how this proposed program is being implemented, and then, of course, we want to see what kind of gaps are also being presented, and then giving the appropriate solutions to this type of problems.
So thank you, and we hope that you are not dropping this project, because it is important, to develop new and probably more related to the nowadays frameworks. So yeah, it is very important, to have not your own, but at least different and more focused on the, as you mentioned, in the hardware or for the hardware systems. Thank you very much for your presentation.
Thank you.
Yeah, and we are moving to the next one speaker, Maxim, as I notified. And Maxim will come up with the topic, which is very new in this upcoming threats and potential actors. So the topic is data protection standards in the quantum era. Maxim, are you here with us?
Hello, hello. Can you see my screen?
Yes, yeah, we saw. Yeah, now it is good. Yeah, now it is good. Please.
My pleasure to present at this conference. First of all, my categorical greetings to Professor Lapata, to Professor Ilona. Thank you for inviting me. So, for this presentation, I'm going to talk about data protection standards in quantum era. It's a very important topic because, according to our research, standards, the existing standards don't talk much about cryptography and majorly about post-quantum cryptography. So the focus of this research is concretely the cryptography and how the standard deals with post-quantum cryptography, and of course we created the corresponding recommendations. So a couple words about me. I am the corresponding member of Georgia National Academy of Science. I am president of Scientific Cybersecurity Association, and I am professor of cybersecurity in Kokosis University. The paper is co-authored with Oksana Kovalchuk, which is PhD doctorate. So first of all, let us talk about motivation of this paper. As I already told you, the existing standards have the problem with cryptography. They don't talk a lot about cryptography, and they almost don't mention post-quantum cryptography. They don't specify how to deal with it. Because of it, we made deep research. We analyzed the existing leading standards. You can see the Mencher, GDPR, PCI, HIPAA, ISO. I will talk about them. And as a challenge, the quantum computers are coming, and quantum computers will be able to break all existing today's classical cryptography. I mean RSA-based I mean elliptic curve based, so all asymmetric cryptography. So the standards must be changed correspondingly. What was our the main research goal? It was to compare encryption requirements across 5 major standards, as already mentioned. In some of the papers, in some of the sections, they talk about cryptography, and let us look about it. The goal was also to identify the similarities of the standards, majorly in the direction of cryptography, to identify the differences, and what are the issues of correct implementation, and to assess how these standards are ready for quantum era. First of all, let us make a look on GDPR. It's European-wide regulation since 2018, and they mention a very strange thing. They have so-called risk-based approach. In the Article 32 and 34, they mention that encryption reduces liability after breaches. And as I told you, they have risk-based approach. They say that encryption is recommended, but it is not obligatory. And I want to mention that GDPR is concretely the law which tells us how to store the data. And still they say that they only recommend to encrypt it, even classically, and they don't demand it. According to our opinion, it's a bit a problem, as tools they offer to use ICIST, TLS, pseudonymization, but no concretics how to use it. Let us talk about PCI DSS standard, which is widely used in financial organization. They have much more strict approach. They say that the data must be mandatory encrypted because it's still financial transactions. It protects hardholder data. They tell to use AES 256 and to use so-called tokenization, so to use tokens when we are encrypting. They transit it. They offer to transit to TLS 1.2 plus, and they rather rigorously talk about key management. According to NIST SPN 857 standards, they talk about HSMS and key rotations. HIPAA, also very important standard which is used in medical organizations in health data protection, majorly American standard, but widely used already in Europe and even in Georgia. And I want to mention here that we deal with the data of people. They are the diagnosis, there is very sensitive information, and still HIPAA says that if you don't use encryption, you must justify why don't you use it. And then it's a problem because we have the information, we have the we deal with very sensitive and important information, so we don't think that it's a good approach because organizations cannot use encryption and just justify why they don't use it. As a recommendation, they offer to use AES and TLS 1.2 plus. Let us look at ISO 2701 and 2702. The same. It's risk-based framework. So 2701 is more risk-based framework. In 2702, they are detailed best practices. They offer to use AES as a symmetric crypto systems array, RSA, and elliptic curve cryptography for asymmetric one. They offer to use TLS and VPN for secured communication. they have very strong focus on key life cycle management. They focus a lot on documentation and policies. Here is a small table where we compared, where we offered the comparison. This stuff a bit interrupts. Where we offered the comparison of the standards. Here you can see according to the standard where it is recommended to use encryption, where it is mandatory, where it is risk-based, where it just offers best practices, and here you can see what they offer for encryption, what they offer for encryption for data which is in transit, which TLS, and how they offer to use key management. Okay, we identified the quantum computing challenges as the major part of the standards offers to use RSA and ECC, which are vulnerable to attacks of quantum computer, concretely Shor's algorithm, and NIST, which is an organization which offers the standards for cryptography. They already accepted post-quantum standards, and it's a problem that they are not inserted into these standards. And NIST already tells us that we should use post-quantum and classical cryptography in hybrid, and in 10 years we should transform fluently to post-quantum cryptography. So for now, the standards don't mandate post-quantum cryptography. The big problem is, as we cryptographers say, to collect the data now. Now we cannot decrypt it, but decrypt later. So when quantum computer will be already widely used, we will be able to decrypt all the data which we gather today. Of course, we understand that there are the migration challenges which are related to cost, performance, and key management. So this must be done very cleverly. First of all, what are our recommendations? So when using classical cryptography, about symmetric cryptography, to use AES-256, not 128, TL to use TLS 123, to strengthen key management, to make the plan to migrate to post-quantum cryptography, as I mentioned. They are already in post-quantum standards. Why not to use them? They are lattice-based post-quantum standards for encryption, and lattice-based and hash-based standards for digital signatures. So our recommendations are already to implement policies to use Kyber or dilithium. The cloud security must be enhanced by means of BYO key and confidential computing, and the big investigation into trainings, awareness about post-quantum cryptography, about post-quantum encryption. So, as a conclusion, I want to say that standards differ. Some of them are more flexible, some of them are less flexible, some of them mandate to encrypt data, some of them don't mandate, as you could see in the table of comparison. Quantum computer is a great threat for cryptography, for cybersecurity, and nothing is in the standards. And the organizations must prepare to use hybrid post-quantum solutions that I already told you. NIST told us for 10 years to use a hybrid of post-quantum and classical encryptions, because if still post-quantum encryption has the vulnerabilities, the classical encryption will be secure against the attacks, and if quantum computer appears, it will break quantum classical encryption. But if theoretically the researchers are correct, it will not be able to break post-quantum cryptography NIST standards. Thank you. Thank you for the attention. Welcome for the questions. If you have any, you can always contact me by the contacts which are mentioned on this slide.
Thank you, Maxim, for your presentation. Do we have question in the audience? Yeah, we have one.
Very much. This nice summary and analysis of standards. As I have a professional background in data protection, I'm a data protection officer of a large IT company. I think one point maybe could have also been emphasized, the problem that in the existing discussion in the data protection domain, encrypted personal data is not considered as personal data if you don't have the key. And this is actually a problem because, of course, it sounds very comfortable because you don't have some legal obligations when the data is not personal anymore. You can do a lot more. It doesn't follow under a lot of controls which the GDPR applies. So there's like a gap where you can opt out and push encrypted personal data somewhere else, for example, into, I don't know, maybe US clouds or something like that. So I think this is one important aspect to address when talking about the relationship of post-quantum and data protection, because we know is just not yet encrypted data. So it's temporarily not personal data, and from the time you leave it out of your premises, it will be collected, as you said, and then therefore encrypted later. So I think this is really important because it's kind of existing practice.
Thank you, very nice mention.
So do we have another question? I have also my thoughts when I see this topic. Maxim, you make my day. Because it is a very nice topic which is related with I'm working with my team as well. Just quick note that EU already released the guidance for post-quantum, how to migrate to the post-quantum resilience phase. So each EU member state should prepare a plan by the end of the year, and these guidelines will impact the NIS2 and Cyber Resilience Act as well. So basically, I hope that next year we will see, some changes in this NIS2 and CRR directives.
Likewise, it's very important. Thank you.
Thank you, Maxim, for your presentation. And do we have? All right. So it means that. Thank you, Maxim, and it means that we are closing our special session on the cybersecurity. We will miss one topic here, which is knowledge graph embedding for the explainable malware family classification. Probably it will be very nice to hear this speech as well. It is related, as I understand from the topic, with the Android defending kind of mechanism, but still we do not have, but we will have some probably free time to talk with the coffee here. And thank you for your participation, and the session is closed.
Thank you very much.
So welcome back everyone to the session 5 part 2 cybersecurity, and we are those who are finishing this conference, so our section is the last one, maybe most interesting, we'll see. So now we have a first presenter of this session, and the paper is the impact of threats in cyberspace on the process of internet fragmentation. So Gamarjoba Maxim again, and please, screen is yours.
Thank you, thank you. Can you see my screen?
Yes, perfect.
Okay. So, first of all, greetings to everybody. I think I've introduced already myself. If still they are the new faces, I am Maxim Yavic, a member of Georgian National Academy of Science, professor of Caucasus University, and the president of Scientific Cybersecurity Association. So, in this, during this presentation, I want to talk to you about the impact of threats in cyberspace on internet fragmentation. So, we have now a rather global project on which we are working. It's a project financed by ICANN. We analyze internet fragmentation for the Black Sea region, and creates a mathematical model using artificial intelligence for ICANN. During this presentation, I will share our very uh, very initial research results, only the beginning of the research, and it's a new project, and we already began to work on this in this direction. The topic is interesting because internet fragmentation becomes more and more interesting and dangerous because the main idea of ICANN that the internet must be united, but some countries already created their own internet, and that means that internet begins to be fragmented. So let us, but in this presentation, I will talk about in this presentation that there are different directions of internet fragmentation, not only political ones, and the focus of this presentation will be the internet fragmentation caused by cybersecurity attacks. So the motivation of this presentation is growing number and growing sophistication of cyber attacks which are related to AI, machine learning, quantum computing, and so on. The global cost of cybercrime, which is expected by 2028, is $13.8 million. And cyber threats can be very dangerous and can cause internet fragmentation because they can destabilize addressing, naming, routing, which will accelerate the fragmentation very much. What is the goal of the research? The main goal of the research is to examine correlation between cyber threats and internet fragmentation. Before, nobody applied mathematical models to internet fragmentation. We began to do it already. We model different directions such as ManDB, game theory, graph-based security, and the goal of the research is to explore whether cybersecurity can be the unifying framework. Let us quickly classify the cyber threats. Insider threats, by means of which the hackers can bypass the security with legitimate access, of course, known for everybody, social engineering, phishing, vishing, yes, all this related to exploiting human factor, attacks using malware, ransomware for disruption, data theft, encrypting data, and so on. APTs, which are still seen long-term and targeted. The attacks on availability such as DOS, supply chain, DDoS attacks, which disrupt the systems. The very big problem of cybersecurity is AI, because by means of the AI, the novel cybersecurity threats appear. Even in the first presentation, who listened to me, I've talked about NIST standards, and on Kyber standard, there was a situative attack by means of AI. Using recursive learning. Of course, this attack was very situative, but still it was an attack. About the detailed analysis of the attack, you can watch on YouTube my analysis of this attack on DevCamp. So, by means of AI, we can automate vulnerability detection, adaptive phishing. The threats are also state-sponsored operations such as espionage, sabotage, DDoS amplification, which can influence on DNS, NTP, SNMP misuse, and of course social engineering, which is persistent global challenge. Let us discuss So let us discuss.
You were unmuted a little bit. Sorry, Maxim, could you repeat last sentence because you muted?
Yes. So let us talk about categories of internet fragmentation. Here we identify only three, which are the main one. Of course, this can be divided also to others, but these are the main ones. The first one is technical, which are NER vulnerabilities related to IPv6, DNS, PGP hijacking, and so on. Here also cybersecurity fragmentation comes. Governmental ones, restrictive policies, different splits of internet where internet already is not unified. Commercial ones, which are market-driven ones, because of platform monopolies, data policies, and so on. Let us talk about ANR security challenges. First of all, we transit to IPv6, and there are security risks in this. What are security risks? For example, vulnerabilities with misconfiguration, and during the misconfiguration, hackers, of course, can use it and break the system. With naming, there are alternative DNS systems which are less secure. Here we talk also about fragmented internet DNS systems for them. Routing, PGP is highly vulnerable. There are the mitigations, of course, using blockchain-based solutions. As I told you, we began to use mathematical models and modeled internet fragmentation from different point of views. First, we modeled it using game theory. Here I don't bring a lot of formulas, which can be boring, but you can check them in the paper. So here we specify different objects the attacker. Different variables are for defender strategies like firewalls, AI detections, and so on. MDP I mentioned, which is market decision process. There we model internet states, which can be global, partial, or fragmented. And also we model it using graph theory, where we have resilience metrics. We measure the fragmentation index by means of it. What are the key findings? So we show that cybersecurity is integral to all of these three categories of fragmentation. So cybersecurity is important to all of them. ANR systems are the primary targets because they have vulnerability, and in the protocols which are used by ICANN, yes, a lot of vulnerabilities are found. The researchers are working, creating the new approaches. Some of them are stopped to use and so on. And of course, as internet fragmentation is a new direction of research, We show that it's very important to use mathematical models in order to provide predictive tools, in order to prepare the defense strategies, to write the policies, and so on. Our final recommendations in this research are that ANR protection must be strengthened, IPv6 security must be strengthened, DNSSEC, which always is problematic. A big work must be done on its security. Also, RPKI must be strengthened. The policies for internet fragmented traffics must be prepared across the borders. Yes. The new directions of cybersecurity must be invested, such as artificial intelligence, AI-driven cybersecurity, quantum safe protocols, as I told during the talk, during the last presentation. And we must further international cooperation to preserve a unified internet, which is the main idea of ICANN. As a conclusion, I can mention the following. Cybersecurity threats can cause the internet fragmentation. To address them, we need technical approach, we need corresponding policies, we need commercial coordination, we need to prepare mathematical models to predict the risks, to prepare the defenses, to make them to be the optimized one, and we need comprehensive multidisciplinary governance. Okay, this is my talk. If you have some questions, please welcome.
Madlaba, Maxim, thank you. So, do we have questions? Any questions? Okay, Maxim, could you maybe be more specific regarding recommendations? You mentioned several of them. Which would you define as the most important or maybe highest priority of the recommendations from your perspective?
I think the NSSEC is very important. There are a lot of attacks on it. And when I was working this year in Michigan, one of the direction of Michigan University, they work a lot on preparing different standards, and they work on creating new DNSSEC and offering it to ICANN. So I think that the main focus must be on DNSSEC. Security and also cybersecurity policies are very important. For example, the internet is fragmented. What should we do? What must we do? We must have the corresponding clear policies for it. And in the frame of our project, ICANN project, we also worked on implementing these policies.
Thank you. So maybe new questions appeared? No. So once again, thank you. And greetings for all the colleagues. So thank you very much.
Thank you, Ilona. Glad to hear your voice.
Thank you. So we will continue. So do we have our next online presenter? Nope. Unfortunately, maybe they will join us later because, again, maybe time difference with China made this change for our conference, but maybe they will join later. So regarding our schedule, I will be continuing this section and I will present our research. And also I would say that for me and for next presenters who will be presenting live, because of the noise outside, recommendation to use this microphone, because for those who are listening us online, has some difficulties to hear us because our special soundtrack behind the screen. Okay, so So hello again. So I'm Ilona Veitaitė, and I will present the topic of strengthening KPI correlation analysis with machine learning for deeper financial insights. This research was done together with Professor Audrius Lopata, Professor Saulius Gudas. We did that analysis during our project related with financial data analysis in some project, which we had a chance to analyze quite a big amount of data set of quite many Netherlands companies, financial data set. And just to have some understanding about this data set, I would like to say that in Lithuania, our companies has a strict template which they need to follow, providing their financial data for the taxes, for the governmental institutions. In Netherlands, they have a bit lighter templates, so it means that providing their data information for the taxes company, they may provide some necessary data and some fields they may skip. So again, having the missing information, it is more difficult to analyze this data, or it is a bit difficult to choose which of data will be useful and will be able to help us to evaluate the results. So basically, talking about financial data analysis, which we did, the main idea was to focus on the analysis of this data from the perspective of a financial analyst or auditor. Because again, to analyze companies' data, if it is one company or two companies, so for the financial analyst is not very challenging because it's his job and it's not very hard to do in some cases. But again, if you have more companies, if you have a big data set for a long period of time, so in this case, sometimes it takes too much time to analyze all the data, and it is possible to skip some important information, like some maybe irregularities, some anomalies in financial data, which may have impact for the company's financial state later, even to the bankruptcy result, which will be the saddest, I would say. But it is possible to evaluate some data to find some irregularities, some anomalies in advance, and this gives the opportunity for the company to improve its performance and to change or correct some mistakes or some problems, or find and improve some errors which were done previously. So basically, this research is part of this project results. In case this topic will be interesting for you, so you may check the previous year's conference papers, because we are presenting our results in continuous manner. So in previous conferences, we presented part of the results, and today we are focusing on the AI and machine learning usage and insights using KPIs correlation analysis to evaluate or to see at least how these KPIs make an impact for the company's financial evaluation, and of course how to make the process of auditor or financial analyst a bit easier and maybe a bit shorter. So talking about this topic in common sense, it means, of course, financial auditing is necessary to show the company's transparency, to show the company's reliability, and to do that in the traditional manner is quite difficult because, again, it takes time. Traditional methods are not always sufficient. Sometimes it is very easy to skip the anomaly or miss somehow some kind of unclear information, and with the usage of AI and machine learning tools, including process mining activities, it becomes more easier. And I would say this results and evaluation may have a higher quality and can help to solve problems which are not yet appeared in very visible way. So one moment. So Continuing, talking about usage of AI and machine learning in financial auditing, usually you may see the concept like auditing 2.0. So the main idea is that in this case we are analyzing real-time information, we are monitoring real-time companies' financial information, and we can of course analyze periodic reviews which were done previously, so historical data, which may have which may give us an opportunity to compare the similarities in financial actions, in financial transactions in previous years and the results of it, and to make an impact for the future activities and provide some suggestions and offers from the financial perspective. Talking about KPIs, again, key performance indicators are one of the most important elements which may help to evaluate companies or organizations' performance level and success. So talking about analysis of KPIs and their correlation from different perspectives, again, it helps us to find and detect irregularities earlier, especially using AI and machine learning solutions. Again, AI algorithms can help to identify the anomalies, some profitability changes, some strange transactions. But again, saying strange transaction or anomaly doesn't mean that it straight goes to the bankruptcy or some problems of the company. It means that this transaction was not quite right or not was like others, but it may be because of additional financing which was received from some kind of project or new investments to some activities. So these anomalies not always mean something bad, something negative, but if they are identified in early stage, so financial auditor may identify and understand the impact. Is this transaction the good one but not the dangerous one? Or we need to think about some changes. And another AI usage benefit is, of course, predictive analytics. So again, analyzing periodic reviews, historical data, current situation, monitoring real-time financial data, it is possible to predict some kind of financial flows, changes, again, maybe some losses, and regarding the losses, of course, try to avoid them. So talking about process mining, which was main focus of our researches previously, so just a little bit analysis of our perspective and some related work. So some main conclusions, basically. Usage of process mining helps to identify, to discover financial processes with the help of discovery of the process maps, process flows. It helps to detect the incompliance, inconsistency, and helps to make evaluation of the transactions more transparent and clear. And also, again, we are coming back to the KPIs and additionally as a part of it, behavioral change indicators, which also can help to identify some strange or incorrect or maybe harmful activities which have impact to companies' performance. Talking about machine learning and AI, again, it's not a news that these tools are used for financial analysis. Again, there is a simple machine learning, which basically it's like a logistic regression, decision trees, which again helps to explain models for the auditors in the easy way. Then advanced AI, neural networks, long-term memory methods, which again helps to use the higher level of predictive results and provide the more effective solution or to make the more useful decisions for the company. Hybrid models, again, which combine the interpretability and predictive power, again, the improvement of AI tool usage, explainable AI, we already talked today previous colleagues presented about explainable AI, which again sometimes has a bit more challenges. It seems it should be very clear and understandable for the humans, but still it's in progress, and especially in the very narrow place like in finances, it's not always very easy to understand. So of course the experience of the analyst must be very deep, so he could use and use properly the given information. So talking about financial data auditing, we have basically three definitions, three concepts which are important. So nature, which automated ongoing verification and ensures that processes are always checked. So with finances, it is very important. Again, timing, so real-time detection. It is always nice when you can analyze historical data, learn from the previous mistakes, but real-time monitoring is also important to avoid future mistakes based on our experience, based on the results we see. And of course, extend full data set analysis. So again, no longer limited to small random samples. We have a lot of data. We have possibility to analyze big amount of data, especially when the companies trust and use trustworthy AI tools, and it helps to make the auditing process continuous. So it means that not only the expert analyzes and follows this information, but also it is done with the help of additional tools. And talking about continuous assurance as a concept related with financial data auditing, again, it is important that it should be combined continuous auditing and monitoring, which basically I a little bit repeat myself, but again, it is important information. Then technology-enabled near instantaneous assurance, where decision makers get timely relevant feedback, because sometimes, again, when a financial auditor finds some anomaly, of course, he provides the report, he provides the information for the CEO, for the company leading board, or for the administrators, and there should be done some kind of the decisions which should help to the company, which should solve the problems which were found. But sometimes, if it is done not in a good moment or a bit later than it was expected, so again, it may have impact to some kind of activities which will make the performance of the company lower level or not as good as it was expected. Continuing about the data set which I described in the beginning, so we were analyzing the company's financial data of Netherlands organizations, and the main idea, the main data set was basically our event logs. And these event logs was given us in the template which I described in the beginning, which is not as the same as in Lithuanian, so it was different. So we need at first to detect which of data is always filled by the organizations of Netherlands and which quite often is missing, and we had to rely only on the event log elements which are filled correctly and fully, and based on that we had to pre-process the data to further process mining activities. And this was quite important because when we already pre-processed the data, when we had the data ready for the analysis, we may and we could identify the anomalies, and usually these anomalies were quite clear, visible with the usage of process mining tools, because previously it looked like some kind of sequence of transaction flows, and only the expert of financial analysis, financial data could find that. So with the help of the tools, we identified these anomalies a bit faster. So one of the results was the calculation of behavior chain indicators to count the potential level of the bankruptcy of the company. So again, it was quite good result. So talking about the balancing real-time monitoring and independence, so again, it seems like real-time monitoring is very important, but independence is also important, because again, sometimes when in real-time monitoring, financial analyst sees some kind of irregular activity, he may or she may do some kind of changes or solutions, and act too early, because sometimes the beginning of some maybe suspicious or strange transition finally finishes successfully, but maybe the way or flow of this transaction was not very clear in the beginning, and financial auditor did the actions in advance but too early, and it was not the real mistake or problem. Then ensuring objectivity while preventing fraud and errors is challenging. So again, auditors must maintain oversight role, so they must follow the information, they must use the necessary tools, and they must focus on the goal, focus on the transparency of the results, and decide which of these results may have impact to the company performance. Talking about machine learning and financial data, to summarize basically what I told previously. So again, the main idea that talking about success factors in this part, so it is accuracy, generalization, resistance to overfitting. The balance is the key, so models must adapt without becoming unstable. So again, if the tools are used, so human factor must be included, the expert opinion must be included, because to evaluate which anomaly or which transaction activity is unnormal can be decided only by the expert, to see, which is able to see what happens next and how can these actions may do the impact to the company. And of course, the risks are overfitting and underfitting. So again, to tailor it to training data or poor predictive performance. So it may have impact to the solutions or actions. So the combination of tools usage and expert opinion is important. So here are some strategies related with preventing overfitting. So there should be allow fair model evaluation on unseen data. So basically data must be also compared with the previous result. The expanded data set size artificially when data is scarce. So again, data augmentation is a fact which helps to avoid some changes and difficulties. The learning algorithms like regularization must prevent overemphasis on noise within training data. So all the tools which are used in financial analysis in advance must be good and well trained and checked by the experts to be used in further activities of the company. And improving accuracy, again, as much samples are given to the tool, it is much more easier to make the training activities more successful. And these kind of tools and actions may have a big impact in the final result for the company activities and performance. And a bit closer to the experiments results, because previously I talked about maybe common idea of the usage of AI and machine learning tools, about the analysis of KPIs, about the analysis of behavioral change indicators. So main experiment related with KPI correlation analysis should be defined here. So we analyzed 56 KPIs across 12 companies from the Netherlands. And in this case, some of the KPIs were correlated by the definition usual equity versus opening equity, and such links reflected structural dependencies rather than analytical overlap. And what we saw, that 49 of these 56 KPIs were not strongly correlated. That means that these KPIs usually are quite independent, and the correlation between them must be evaluated from the perspective of the expert to evaluate the final result. Also, talking about visualization, we had quite many results, and for example, correlation in heat maps again showed sparse clusters, which confirmed the idea that these KPIs in majority are independent ones. And in this case, it is better to include more additional usage of machine learning after the improvement and good training. So basically, main result was that correlation analysis as a separate solution is not sufficient enough, and it is important to choose the KPIs from the perspective of what we need to analyze and what kind of actions should the financial analyst do. Then what regarding unique information. So again, majority of KPIs retain standalone value, and this strengthens the idea that they are all, it is important as a set of KPIs, it is important for machine learning driven auditing. And cross-company consistency, as I mentioned, we had analysis of 12 companies, so results were repeated across multiple firms. So this information is confirmed that generalizability and robustness of findings beyond single data sets. So again, the similar activities was visible in all the companies, in majority of the companies we analyzed. And talking about impact on machine learning, so smaller KPI sets improve generalization and reduce overfitting. So despite the fact that we have a lot of data, a long list of KPIs, it is important to split them into the sets so we could analyze them in more detailed way and to see more accurate results. So concluding the topic, so machine learning and AI transform auditing into a continuous proactive oversight. So it helps to detect and prevent some actions of the companies, and again, detect anomalies and prevent possible bankruptcy. Usage of different type of tools should be balanced, and it again has to be organized by the financial professionals, financial experts, with, of course, experts which are using AI and machine learning solutions and providing them to the companies. Then talking about unique insights, so again, KPI analysis shows and suggests that the redundancy is limited in financial data sets. So again, I'm repeating, if we have a long list of KPIs data set, it should be split in separate sets regarding on our main goals. Then continuous auditing, of course, improves fraud detection and risk management. So if the company analyzes its financial data periodically, especially real-time monitoring activities are held, so of course then the company is more resilient to financial shocks and may avoid any negative consequences after the maybe some strange or in not common activities or transfers. So regarding the challenges, we have still to evaluate the ethical risk, regulatory alignment, and the AI tools which are used especially for the financial data must be secure, because financial data, of course, is for the company very sensitive data. So again, the tools must be evaluated from the security side. Talking about correlation analysis, so what we found that KPIs is quite a good solution. The correlation of KPIs is quite effective one, but it's not sufficient to be as one of the analysis elements, and it should be combined several of them. And future vision, of course, to integrate process mining, AI, machine learning, and not to forget financial experts' opinion and evaluation of these tools. So that's what I wanted to say. So thank you very much, and hopefully maybe you have questions. If not, you may mail me and ask. Yes, we have question.
So, you know, I initially expected some particular algorithm, some machine learning algorithm, and the experiments with this algorithm. So, but still, your presentation is nice. But what kind of algorithm do you use?
We analyzed the KPIs from the Netherlands companies. We adapted several of the solutions and several tools, more from the correlation requirements and mathematical rules to evaluate the relation between these KPIs from different companies. So in this part of the research, we presented more like the idea of how these tools can be adapted to the financial data analysis, and in the future works we are planning to present more detailed presentation of the experiments itself, because to say that from 56 KPIs 49 was not bad, it was not the best result, but it shows that after our analysis it has the potential to be analyzed in deeper way. So basically we have a lot of future works to do.
Yes, okay, I wish you success. In the
Thank you
future
very
work.
much.
So thank you.
Thank you. More? No. Thank you. Thank you for question. Thank you for the comments. And now we have one more presenter. So there will be paper comparative analysis of generative AI model efficiency in Chief Information Security Officer CISO tasks, and it will be presented by Rokas Stankūnas, and I think I will give you a microphone.
Thank you so much. All right. Yes. I'm never too sure. Is it better to sit down or stand up while doing these kind of presentations? So I'll try to stand for now. So I hope you're not too bored. I'll try to make this as easy to understand as possible. And I will present the topic of comparative analysis of generative AI model efficiency in Chief Information Security Officer CISO tasks. So in general, with the evolution of organizations, with the evolution of legal regulations, it is very obviously visible that companies are investing more and more into cybersecurity, and in turn, their security operations are just becoming more and more complex. And by natural design, that means that generative AI is being introduced as well into these operations. And as any other tool, it has its own positives and negatives, operational risks. So with this study, we try to qualitatively examine how well would these models actually perform when completing any kind of real cybersecurity tasks. So yes, as with our research, we have decided to focus on measuring how well does the AI handle the actual task and measuring the efficiency of it. We tried to go through all 4 AI security domains, and of course, when doing any kind of practical testing, to actually align it with the relevant laws and European Union regulations. So, as per our experience, we only limited ourselves with the OpenAI selection of models, so GPT-4o, 4, O1, O3 Mini, O3 Mini High. When doing our experiment, we provided 5 distinct prompts to the models and ran the test 3 separate tries just to ensure to get some sort of consistency. And of course, this allows us to see how well does the model actually work. As per the security domains themselves, for all of the domains, we try to compare if the AI how well can it process structured information, how well can it work with unstructured information, how well can it quote-unquote, find the needle in the haystack, deal with bigger amounts of data, and find anything useful, how fast can it do it, and of course, at the end, is it able to do any kind of visualizations and graphs. So, as per the actual responses, we measured the responses with the amount of tokens, and we used that primarily to measure if the model was efficient in that specific use case. As per the work itself, we wrote 3 hypotheses so that we believe that the models themselves are going to have varied answers just because due to how they were trained and the differences in their architecture. Some models, due to these differences, might ask for additional context, which in turn might improve accuracy, but at the same time might reduce the same efficiency because it requires more tokens. And of course, as it happens, we expect that these models will also provide contradicting information between each other. So, as per the model characteristics, here's a small, detalization. The main thing is that some of them are more general purposed, and some of them are more fine-tuned to reasoning. So yes. The prompts themselves, when we were actually executing the scenarios, we only limited ourselves on the physical security domain, and we chose to answer our to respond to our made scenarios. Yes, as per the responses themselves, we asked them we provided information in English, expected information in English. We told the AI model so that, hey, you're a CISO and you have to provide an expert response. Try to be as specific, precise, context-aware, and avoid any kind of clarifications unless it is absolutely necessary. So this is the main workflow of the whole experiment. So basically, there's a couple of steps that I would like to quickly gloss over. Is that first we got the legal requirements that were defined by legislation for the CISO person. We sorted them into the different security domains. Then we classified them into the dimensions. Afterwards, we made we thought of criteria that we could use for actually creating the scenarios. Then the supposed CISO person actually wrote the prompts, like I mentioned before, ran them through all the models. We got all the information, picked out the most efficient model, and if we saw that there was any kind of obvious hallucinations or any other need to correct the scenario, then we, of course, ran the loop again, or if not, we have our own answer. So, as per the prompts used, what we actually provided to the AI, we gave them 5 questions. Can the AI detect anomalies in security logs? Can it detect unauthorized entries from an MP4 surveillance footage? What is the maximum size that the model can process? How long does it take to analyze, for example, 100 megabyte file? And, for example, can the model process sensor data for compliance with the NIST2 directive? So, as per one of the first things that we noticed was that models gave different answers to the same questions that we asked them, even if we provided absolutely identical conditions. One of the most interesting ones that we noticed was that the model GPT-4 and O1 provided conflicting answer on when we're asking him, hey, what's the biggest file size limit that you can actually process? And it doesn't know precisely. It only relies on the data that it was trained on, not the actual limits that was set by the developers of the model. Of course, we noticed that since generative AI uses probability, the answers are varying, and the higher the temperature is used on the model, it becomes more creative and it becomes less consistent. During our tests, it is worth mentioning that since the web interface doesn't allow us to vary the temperature much, so the randomness was unavoidable. As per the expert evaluation, then we, of course, saw that the responses often switch between abstract reasoning and technical details. That means that they weren't really consistent. They were jumping in between. Some models also struggled with quantitative prompts, giving vague or contradictory answers. And some models favored direct answers, while others used as much clarification as possible. Yes, and as per the actual measuring of the efficiency, as I mentioned before, we just calculated the tokens. Roughly 1 token is 4 characters. And technically what that means is that the fewer tokens used, that means the faster the response was actually calculated. And we use the tick token library to calculate them. This is a table which shows how many tokens were actually used. I'll quickly gloss over in a separate slide. The only thing worth mentioning is that the inputs were, of course, a lot higher, but they also use a separate encoding, which kind of skews the results. As for the other numbers, here are they visualized on a bar chart. As we can see, GPT-4o used most tokens on average per our experiment, and the least was O1, which used a lot less. But at the same time, I'd like to remember that if it does ask any kind of clarifying questions, then of course the token count goes up. So as per that, we can basically conclude that this efficiency is it must be balanced with the accuracy and reliability. Yes, yeah. So the Gen AI models produce significantly varied and non-uniform responses, confirming the need for rigorous and model selection. There's also always a trade-off. If there's a higher efficiency, it does not always guarantee high effectiveness, requiring external validation. So as the regulations require us to do any kind of manual testing, this basically just confirmed it. And when we were looking for contradictions, it also confirmed the inherent risk of inconsistency within the same model, underscoring the need for more testing. And of course, the future research will expand to expert-based effectiveness testing, ensuring that efficiency does not come at the cost of accuracy in real-world cybersecurity operations. This paper was written, of course, by the funding of Research Council of Lithuania. I thought that's worth a mention. And we also have, as per our project, some socials. So if you would be interested, we would appreciate it for a follow. And that will be it. Thank you. I would appreciate the questions.
So thank you very much. So I cannot ask questions because I know everything from here. So maybe questions from, okay. Mm-hmm.
Normally I win the trophy for the fastest speaker at such conferences, but I think you're a very worthy competitor for me. But what I wanted to bring in terms of content, you relied completely on OpenAI, so it's a completely cloud-based system, and I think this is, I know it's for open research purposes, but I can say that it's kind of sensitive. You will not use an US cloud for such topics within the European Union, not even a European cloud provider for such topics. So I think it would be for next steps very important to look what local AI models can do, because you have to be in full control of the data and what the models are doing.
Yes, that's a very perfect observation. Thank you so much. Because exactly, with the whole evolution of our legal regulations, they do mention that, well, if there is any kind of data that we're processing in the European Union, it must be processed via our, safety regulations. They have to be enforced. So, and yes, and there are some sort of concerns that if it's located outside of the European Union, then yes, it is. It might not be the case, certainly. So yes, and in our future research, we'll try to use different models, and we'll see how we can actually accommodate this, that we're checking models that are hosted specifically in the European Union. Thank you. Anything else? Any questions, comments? Yes.
And also thank you for the presentation. And since you mentioned that there was something unpleasant, unflexible with web interface, have you considered using a locally installed LLM?
Amazing question. Thank you. Of course, we have discussed all things. It really depends on how the project pivots. Our main goal was to try to as many different models as possible. For this very specific case, maybe the easiest solution would be maybe to try to use the API next time. But of course, testing locally hosted LLMs would also grant some very interesting insights by themselves inherently. So yeah, thank you. Okay.
It seems we do not have more questions, but just in case if you are interested, you know where to find. Click back a little bit. Yeah, here. So all the information and updates are here. So thank you very much. And we have, I suppose, last presenter for today. If our Chinese colleagues may be joined. Nope. Okay, so last presentation, enhancing static code analysis with AI-assisted detection of security vulnerabilities and code quality issues. So please.
Thank you. Okay. I'm standing good. You can see me on the camera. Okay, so I'm Augustinas Lubitis, and today I will be presenting the enhancing static code analysis with the AI system detection of security vulnerabilities and code quality issues. So to start off, what is the motivation behind this type of research? Well, first of all, it's the increasing software complexity. The microservices architecture evolving zero-day threats, supply chain attacks, and of course, with the addition of large language models used in programming, the software complexity keeps increasing. Then the second motivation for this kind of research is that traditional static code analysis tools usually provide some false positives and false negatives, and also misses the contextual clues from the program code. And of course, the third reason is that developers always get burdened by all of the false positives and the false negatives from the static analysis tools. So what about the related work? Well, the related work usually talks about software development cycle and some exact parts like programming, planning, testing, and securing, but they do not talk about the whole life cycle, how to secure the whole life cycle. Then additionally, traditional static analysis tools are rule-based and they are context-blind. And AI and software engineering is gaining traction, but frequently is used for defect prediction and not vulnerability reasoning. And of course, necessity arises for a hybrid methodology to integrate formal analysis with contextual learning. So the aim of this research was to develop a hybrid framework that uses static code analysis and AI to analyze program code, then to enhance the precision of said methodology, offer some sort of comparison between what was used before and what was created, and then to incorporate the prototype into continuous integration, continuous deployment pipelines. In the hybrid methodology overview, we have created this type of cycle that we collect, we prepare the data, we collect and label what is secure code and what is insecure code. A great example for that is OWASP, top 10 most common vulnerabilities in the web. Then we run the baseline analysis. It can, for example, on C#, it can be SonarQube, Roslyn ReSharper to get initial findings. Then we get a report of what kind of warnings, errors, or information we get in the existing code. Then we introduce an AI layer to introduce false positives and false negatives that will detect emerging patterns and suggest fixes for the developer. And then validation part, we check what the AI has created. We run some sort of automated test. In the prototype example that I will talk about, we used just to build a program that we have created with the AI layer. So as you can see from the picture, at the top there's a programming cycle. It's basically when the program is being created, all the testing, planning, and programming. Then we run it through static code analysis with our enriched secure coding practices. And in the AI-assisted layer, it identifies false positives, detects emerging vulnerabilities, and provides the code suggestions or improvements. And after all of it, the code is compiled once again, so we can check if it didn't introduce any additional defects. So in the experimental use case, for the prototype, we used GitHub Actions, GitHub, and OpenAI LLM. It's not mentioned what sort of LLM, because pretty much all of them had pretty close performance in our prototype case. Then the scenario is C# code with SQL injection via string concatenation. And the flow is basically the developer creates some sort of program, he pushes it to a code repository, in our case, GitHub. Then we run the baseline static code analysis. We run the static code analysis and paste it to OpenAI LLM. We get code suggestions and an explanatory message why the vulnerability was bad and what needs to be fixed. And then we compile the program once again. So here's the example of the output of our prototype. On the right, we can see the fixed code that is highlighted green. And on the left, we can see the previous code that was vulnerable for string SQL attacks via string concatenation. And then we have, in the top left, we have a simple message that explains why the vulnerability was bad, how it was fixed, and what can it do in the future if it remains unfixed. And how do we compare if what we actually created actually fixed something? So the goal was to capture detection quality and how much noise it reduces. So the components of the formula we created is the baseline static code analysis signal, and then what the AI found was verified. Then we introduced the penalties, which are false positives and false negatives, and how much AI suggested the accuracy and the resulting code quality. And how do you interpret this formula is that the higher the score, the better our prototype performed. So what about the results and the interpretation? So from the results, the detection accuracy increased, and on the code samples that we have tested. It also reduced the time to analyze what sort of false alarms were generated, what false alarms were generated, and it assisted developers, novice developers I should mention, with in-context fixed suggestions so they could understand what is wrong with their program code. So what are the limitations and threats to our research? The first limitation is that it would consume a lot of hardware to run the AI detection on the whole repositories, because as more code appears, the more resources we need. Then there's differences between each program language, so it will be hard to generalize it for every programming language. Then explainability is very crucial for sustaining developer trust and fostering adoption of this type of method. And what are the threats to validity? Well, of course, because we use a very small data set, it restricts diversity and may be dependent upon particular code bases or categories of vulnerabilities. Then there's possible bias in AI models, because if you train the AI model on some sort of code formatting or just coding style, it will be represented in the fixes it provides. And then we only evaluated the performance on controlled environments. So what are the takeaways? The takeaways is that hybrid method with AI and static code analysis reduces noise and catches some contextual flaws. Then the composite metric ESCA enables comparative comparison between the old methodology and this hybrid one. And what would be the future work is that we would have to introduce broader data sets, do more testing. Then we would have to create stronger explainable AI components for transparency. And then we would have to deploy it in the real world, see how it performs in production code bases. And if you want to collaborate, here's my email. You can feel free to reach out, and I'm ready for questions and answers.
So again, thank you for your presentation. Could you specify how large your data set was for training the prototype model?
Well, for this prototype, we didn't do any training. We just provided what sort of static code analysis rules you should react on. What kind of fixes he should do, there was no providing. It was basically what is inbuilt into OpenAI LLMs.
Okay, thank you.
You emphasized computational power required for what you're doing, but you did not identify, or at least in an outlook mention that smaller language models or specialized language models might be more appropriate actually for the problem you're having, because of course you don't need a language model which is able to quote Hamlet when you do code analysis. So I think, did you consider thinking beside the open AI marketing gags of having to need these big AI models for solving every problem?
Yes, thank you for the question. I would like to say, pretty much, we think the OpenLM AI was used just as a prototype. We would think that there should be an AI layer. I don't know, maybe it should be machine learning model, or maybe some sort of specific LLM, like you mentioned, but it would be probably in the future, not in this prototype.
So, yeah, well, actually, thank you very much. It was very interesting presentation, and well, among the limitations, you were mentioning different languages. So, could you give some examples, or maybe further considerations?
Well, the problem is that we occurred. At first, we tried to do it using the UI of ChatGPT. What happened, because I'm a C#, I have a C# background, I couldn't get the OpenAI to generate Python code at first. So basically, that is the main problem. If it only knows how to do the C# code, it will probably not print good Python code.
Thank you very much. So thank you for all presenters, except the Chinese ones, because they didn't join us today. So as I said, this is the final section, so we are concluding this conference. So firstly, thanks for the organizers for this event, for this 2 days amazing event, and thank you all the participants.
And I'm very thankful for contribution to chairing this session for Associated Professor Dr. Ilona Veitaitė from Vilnius University. Thank you very much, and I would like to honorably give this certificate. Yes, so thank you very much, dear colleagues, and of course, this is not very final event, yeah, because we have best paper awards and conference closing kind of procedure, and today, this year, best conference goes to, guess. Okay, so the best paper awards goes to Filipo Sanfilippo, Patrikas Armalis, Ugnė Auksolaitytė, and Tomas Blažauskas. Yeah, this is international team, and we are proud that we have international team which in general do good work, yeah, and the research was very impressive, yeah, in general. Very impressive. And the name of the article was Structuring Immersion Levels in the Relative Virtuality Continuum, a Multi-Sensory Approach. So, thank you very much. Thank you very much. And Best Paper Awards goes to international team. Do we have members of his team? Oh, okay. So, please come here. And okay, so thank you very much. And this is yours. And maybe German photo. So, dear colleagues, thank you very much. And now I think all of us are very tired because we had 2 days very, very intensive kind of schedule, yeah? So today I would like to ask you to go to relax, to have some refreshments, some food, some, in general, some dinner, yeah? So thank you very much. And this year, very, very sadly, but I should announce that the conference is closed. Yes, we had a lot of work. Thank you very much. Thank you very much again for all the participants, for all the chairs, for all the reviewers. So all of you did very huge work, yeah? And I'm very, very proud. I'm very, very proud. And thank you very much. And I hope that next year we will have much more scientific community right here on site, yeah, because, you know, we can feel that during, let's say, past next 2 or 3 years, the on-site community becomes a bigger and bigger and bigger because, you know, during our this 3 years ago time, so we had only, in general, we had only the remote sessions. So now our on-site community growing. So it is good times. I think that it is very good tendencies, good trends, and thank you very much. And I think that I hope to see you next year approximately at the same time. The more detailed schedule will be announced during, you know, during next, I don't know, 2 or 3 weeks, because you know, when we are closing the last section, after 2 weeks, we are starting to organize the new conference. So it's, you know, it's reality. It's reality. And thank you again for staff, for technical staff, because we avoided any technical kind of misunderstanding and problems. Thank you for Volker. Thank you very much. Thank you for Volker and his team. Thank you for all the organizational staff. Thank you for all the organizational committee. Thank you for all who helped to organize this event but did not mention it. Thank you. Thank you very much. Okay, thank you, and so see you next year.